If you are familiar with Jabril's, you know that he is one of the most entertaining tech creators out there. YouTube, the company, asked him to create a full programming course, and we are proud to be able to release the entire course as one video on the freeCodeCamp channel.
Yo guys, all my life I was told programming was hard. It's only for the nerds. It takes so much maths. Your grades aren't good enough. But having programmed now for 13 years, I can confirm that all these assumptions are false. And that is why when YouTube recently approached me with the opportunity to create an entry-level programming course, I knew this was my opportunity to try and correct some of the misconceptions that I'm sure are still preventing average people like you from diving into the amazing world of programming. But first things first, we have to knock it off with this Hollywood dramatic feel. So, you want to learn to code. I mean, I don't blame you. Forbes ranks computer science as the second most valuable major to learn. Now, of course, you could just go to your school and learn how to program, or you could just learn how to program from a dunce like me that has no traditional schooling background. Wait, hold on. Before you click off this video and sign up for a course at your local university, let me at least try and win your hearts with a quick story. Jeez. It all started when I was about 9 years old. My friend invited me over to play this new game that I had never heard about.
Yeah man, it's crazy. You get to play as Donkey Kong if you want, and fight against Link, Mario, and Pikachu.
And sure enough, he was talking about the original on the Nintendo 64. And like, I had always played video games, but there was something about this game that from that day on had me obsessed with video games. I remember when my family moved from Virginia to California in 2000. The whole drive across the US, I was designing my own Smash Bros levels using a little pen and notepad. And when Christmas came around, I asked my mother for a Nintendo 64 with Super Smash Bros. And I played that game for countless hours, absolutely captivated with the concept of it all. Iconic Nintendo mascots all together battling it out in a video game in 3 dimensions? How was something like this even possible? This whole experience is what got me interested in wanting to understand more about how video games work. No, not to learn how to program, because I was still at that age where I was still learning to read, write, and do basic maths. Again, it got me interested in wanting to learn how games work. And remember this, because this will become important later. It wasn't long after that until I came across a little website called newgrounds.com, a place where people like me were making simple, low-budget games and interactive movies. And I believe this truly to be the experience that planted the seed in my head that making video games like the ones that I loved playing was actually possible for someone like me. So, a little later in life when I came across something called Game Maker, which advertised itself as you can start making games today, no code required. And after weeks of begging my mother to buy it for me, she finally did. And man, that was such a fun time in my life. I had absolutely no idea what I was doing, but just doing the best that I could to create logical statements that would make a computer do what I wanted to do was enough to get me hooked. Feeling that sensation of being truly tired for the first time because I stayed up all night trying to understand how to create an inventory system is something that I'll never forget. From that day forward, I continued to learn as much as I could, asking all for help who were willing to help me, learning more and more, not about programming, but about how games work. Because you see, understanding how games work is what initially drew me to programming in the first place. And without even knowing it, that is what I would always fall back on when times got rough during my coding adventures. And so, moral of the story is, I know what it's like to have an extreme urge to learn this stuff, while being not exactly sure where to start. So, I know exactly what you're missing and how to get you on this side of the fence. And thankfully, I've learned how to do all this stuff without traditional schooling, which means you and I, we speak the same language, huh? Now, if that story didn't win over your heart, you probably don't have one. No, I'm just kidding. But I'm sure that this will. This here's my friend Zarglar. Zarglar is a highly intelligent programmer that has, no joke, programmed literal entire star systems solo, using only a TI-80 calculator. And when I told Zarglar I was going to be making a programming course, he would not shut up about wanting to teach it for me. Now, Zarglar is a quintillion times smarter than I am. But why do you not want Zarglar to teach this course? Well, watch this. Zarglar, what is an array?
Well, you see, we need a bit of a backstory because traditionally memory could only store information at a 32-bit rate, which made recursion difficult to pull off. But when Moore's Law gained traction in 1996, we not only attained more power and memory usage.
Okay, Zarg, you've proved my point. This audience didn't understand any of that PhD programming slang, mate. It's time to go. And next time, remember to breathe.
Oh, man.
So, welcome to my course. In this series, you will leave with everything you need to start programming. Yes, you've read the title right. This is not clickbait. In fact, by the end of this course, you will write your very first application utilizing everything that we learned. But if you are to remember anything from this course, please let it be this. Ask yourself, why are you here? What has drove you to want to learn everything you need to start programming? Again, for me, it was to understand how games work. Whatever your reason may be, I encourage you to write that reason in the comment section now. And if at any point throughout this course, or hell, throughout anywhere in your programming adventures things get tough, I want you to return to that comment to be reminded on the reason why you started. Trust me, you got this. I promise it's a lot easier than you think, and I'm gonna do the best I can on the communication side of things to make it even easier for you on this course. I will see you on the next part. Yes, it's so tight to see that you've clicked on this video and are interested in learning some programming principles. Well, I'll tell you one thing. If you want to become a programmer, you aren't gonna get very far without this thing. This is called an IDE. There are many different types of IDEs. Some from large organizations that you've definitely heard of, like Visual Studio from Microsoft, Xcode from Apple, and Android Studio from Google. But there are also IDEs from various other organizations as well. PyCharm from JetBrains, Eclipse from Eclipse, Sublime from a couple of dudes, Atom from GitHub, just to name a few. And as you've probably guessed, today's lesson is all about IDEs.
Hey, what does IDE mean?
Oh, duh, of course. How could I forget to cover that? IDE stands for Integrated Development Environment. And just as the name suggests, it's a digital environment used to develop games, software, hardware, just about anything with code really, that offers integration or control over many aspects of development. From debugging, which means adding, removing, or changing code that prevents your program from running as intended, all the way to compiling, which roughly means taking your code and turning it into something that computers can understand. Some IDEs support just a single language. For example, idle, which is an IDE that is bundled with the language Python when you download it, and it only supports Python. But IDEs like Xcode from Apple supports a bunch of different languages, like C, C++, Java, Python, the list goes on. But as you see, my point here is that there are many different options when it comes to choosing your IDE, and honestly, it can be a bit intimidating. But again, if you want to start programming, you need an IDE. Later, when you get more experience under your belt, you can use Microsoft Word to write your programs if you really wanted to. Though, I would not recommend this no matter how much experience you get. You'll be wasting a ton of time. And that is what an IDE is. A digital environment that is a very essential part of programming. Whether you want to code some games, software, hardware, you name it, an IDE is your best friend to help ensuring your success. It's now time to install your first IDE. Are you ready? Let's do it. And heads up, there are many different IDEs out there, but instead of walking you through each and every IDE, which would be a very boring lecture to sit through, you're instead going to get my bias, and I'm going to show you how to install my two favorite IDEs, Microsoft Visual Studio, which should interest you if you want to get into Windows development or want to make games using a popular engine called Unity, and we'll also be installing Microsoft Visual Studio Code, which should interest you if you're interested in more general programming or data science, as well as a slew of other tasks. And yes, they both have Microsoft Visual Studio in their name, and yes, they are two separate IDEs. Now, let's get started. Alright, so the first thing you're going to want to do is open up your browser. I'm going with Google Chrome as my browser. You can choose whatever you want. This part's not really important, but you want to search Visual Studio, in the search bar and then click downloads. You'll see visualstudio.microsoft.com. Click downloads and it'll take you straight to the page that you want to be on. So as you see, we have here Visual Studio 2019, the Community Edition. Let's hit free download there. And then you also have your Visual Studio Code IDE. Well, hold on one second. You'll see that it pops up down here, lets you know that it's downloading. And then I'm going to go back and then I'm going to click Visual Studio Code. Free download. This is the second IDE we need. And it'll pop up down here, let you know that it's downloading. And you just wait for that to download. All right, once those are done downloading, you can either click on them from here in Google Chrome if that's what you're using, and they will start to install it. But if you don't have Google Chrome, then you're going to want to find wherever your default downloads folder is. In most cases, it should be downloads in Windows, C downloads. But if not, you're going to want to find that so that you can install the IDEs. So first, let's install Visual Studio Code. I'm just going to double click on this and you'll see that we get a window here that says welcome to the Windows Studio Code Wizard, Setup Wizard. And this part's really easy. It's just like any other installation you've ever done. You just hit next, then you agree, read it if you want, hit next. And then here you want to leave this at the default location, which is like C somewhere program files likely. But because I already have this installed on my system, I'm gonna install this in a very special location so it doesn't mess with my presets. So yeah, just leave that how that is, hit next, and then just hit next. And here I would recommend that you check open with code and on both of them, and also make sure that add to paths is checked as well. And what these two do here is it allows you for, like, let's say you have some Python script, and instead of having to open up first Visual Studio Code and then hitting file and then open and then searching for it, you can just go to, like, let's say one of these are a Python script. You can just right click on it and then you'll have this available right here where it's open with code. So it will just open that file directly in Visual Studio Code. It's very convenient. You can also do that with directories in case you have a file, you have a folder with a lot of Python scripts. You can just right click somewhere in the folder, hit open with code. Very, very useful. I would definitely recommend checking both of these. And then just hit next. Now I'm going to go back and remove these because, again, I don't want to mess up my presets, but this is how yours should look with, of course, the destination being C program files, whatever. And then after that, just click install, and then you can see that it's going to install. It's only going to take a couple seconds. It's not going to take terribly long, and bada boom, there you have it. Visual Studio Code has officially been installed. We're going to hit finish and launch Visual Studio Code. I'm going to bring this, wrong window. Going to bring Visual Studio Code over here. This is what it looks like. Now, before we get started, there's a couple of things that you want to do. You do definitely want to add Python right here. So click install. In fact, I'm going to show you how to do it traditionally. Just search Python and then install just Python. This allows you to use Python with Visual Studio Code. And there are a few options to do that, but this one is straight from Microsoft. So just install the top one that's just called Python. And another extension that we're going to need is called Code Runner. Just search Code Runner, open the extensions, and download the first one. This is going to allow us to run our Python scripts within Visual Studio Code without having to leave the IDE. It's very nice. All right, and there you have it. Visual Studio Code is installed. If you want to do new file, just go to File up top, New File, and bada boom. If you want to save an extension, you just simply save the file anywhere. We'll just do documents, for example, and just do like my file, I don't know, .py. We'll get you a Python script, hit save, and now it's recognized as a Python script. And if you get this pop-up here that tells you that Python is not installed, Visual Studio Code is often really good with letting you know like what you need and what you, well, not so much don't need, but they're really good with letting you know what you need. So let's hit download here. It's going to pop up a new window. We're going to want to download Python 3.7, and then I'm just going to hit run. Oh, I'll just hit save. Open folder here, and I'm just going to double click that to run it. Next, all you want to do is just hit add Python 3.7 to path, and then just click install now, and it's just going to install now. Give it a little time, and Python should be installed. And just like that, setup was successful. So back in our downloads folder, I'm just gonna double click the Visual Studio installer. And I'm not sure what you're seeing right now, but it's asking me to type in my password. So I'm gonna do that. Let's see, hold on. No, it's not. Oh, the pin, sorry. All right, sorry, I went black there for a second. And then we have Visual Studio installer, just hit continue. And it's gonna start downloading and installing some stuff. Shouldn't take too long. Then you should see something like this pop up, and they're gonna give you a few options. You can ignore most of them. Maybe come back to them later when you get a bit more experience. But all you really need is this one right here, .NET Desktop Development, because what we're looking for is the console applications using C#. So just click that one, and then you just click install. And let's see, install on system drives recommended. Again, I have this already installed, so I'm going to place this in a very special location, but definitely place this installed on your system drive where it's recommended. So I'm gonna hit OK, and you get this that pops up. Thank you for installing. Take a survey. Not now. And this will start installing. It's probably going to take a little while, but once it's done, you won't have much to worry about. All right, and once it's at 100%, give it a second. It's going to start automatically because we had that checked. And bada boom, now you have welcome, connect all your developer services. Just hit not now, maybe later. At some point, they'll force you to make an account anyway. So just for now, we'll do not now. Start Microsoft Visual Studio, preparing your first time use. And here we are. Now, if you want to create a new project, you simply just hit create a new project, and then it'll ask you what type of project you want to make. We're just going to do a simple console project in C# here, and then hit next, and you can name it. Let's just name it. Oh, just leave it how it is. Console project 1 is fine. And create console app. Sorry, I don't know how to read. Give that a second, and bada bing, it'll start up, and now you're officially in. And that's pretty much all that you have to do for C#. So if you want to program in C# and or Python, it's important to understand their syntax. But first off, what is syntax? Well, syntax in relation to programming is pretty much a set of rules that must be followed, an order of operation that your code must abide by, a process that must be respected if you want your program to run. And so today, we're going to look at the syntax for two different languages and see the differences between them, because I think it could be really helpful for you to see how they compare and contrast. And plus, you'll pretty much learn two languages at once. And so on the left is the language C# using the IDE Visual Studio, which should interest you if you want to do any Windows development or want to make games using a popular game engine called Unity. And on the right is the language Python 3 using the IDE Visual Studio Code, which should interest you if you want to get into general programming or data science. Alright, so here I have two brand new console projects. So the first thing I want to look at today is how both languages go about utilizing data types. Now, data types by themselves are useless. You have to assign a data type to a variable. Now, to get started in C# over here on the left, I'm just going to get rid of these two lines because I no longer need them. They come stock with every new project. And then we're going to use a Boolean as our example today. Now, a Boolean is a type of data that can only be one of two types. It's either true or it's false. So let's initialize a Boolean in C#. Let's call it do it. And then we're going to assign true to it. So do it equals true. Now, this is all great and all. Do it is a Boolean that we assign to be true. However, C# will not recognize it as a Boolean unless you cast its data type. And in C#, you simply cast the data type by going before the variable, which again, our variable is the do it. Before it, you just type whatever the data type is. So this is bool, which is short for Boolean. Bool do it equals true. See, our error goes away and everything checks out. And this very syntax goes for every variable. For example, if you want to initialize a string variable, you have to cast it. So I'm going to say this is a string. I'm going to call it str, short for string. And then I'm going to assign hello to it. For example, You have to do this for every single variable. However, there's a bit of a catch. So I'm just gonna get rid of this line because I don't need it anymore. You only have to initialize your variables on their first use. So like if I wanted to change the doit boolean variable, I just have to come down here and I can do doit equals false, for example. And that's because when on this line right here, the program knows what the data type for the doit variable is. It knows that it's a bool, so I don't have to do it again. In fact, if I try and do it again, you'll see that I get an error. This error is pretty much just telling me that like I can't create the same variable twice, essentially. So just remember, you only have to initialize on the first use, and this convention is for every single data type. That's booleans, that's strings, that's integers, that's floats, every single one. Now over in Python, things are a lot different. So let's say we want to do the same example. We just want to initialize a Boolean variable. Well, in Python, all you have to do is just write the name of your variable and then assign whatever value you want to it. So in this case, we're going to assign true to it. And there we go. We just initialize a Boolean variable. That's right. In Python, you don't have to cast your variables. You don't have to cast the data type of what you want your variable to be like you do in C#. And this benefit comes from the fact that Python is what's called an interpreted language. And what that means is all you have to do is create a variable and then assign some value to it. And depending on what value you assign to your variable, Python will interpret what type of data type that variable should have. And with this syntax, it enables a lot of flexibility with the Python language. It's one of the reasons why so many people love Python, because it's kind of like a breath of fresh air as far as computer languages are concerned. And it's one of the reasons why a lot of developers that are into data science and whatnot use Python, because as you can see, you can save a lot of time not having to type, the data type over and over and over for your variables. However, the flexibility doesn't stop there. I'm going to simply print out what doit equals, like so, save it, hit the play button, and you'll see that doit equals true. Obviously, that's what you expected. But check this out. If we want to reassign it to be false, for example, we just come down and say doit equals false. Save it, hit the play button, and we have a false value. But this is where it gets really cool. So currently, as you understand it, doit is a Boolean variable. But we can do doit equals 13,037, for example. So first we assign true, and then we change our mind, assign to false, and then we change our mind again and assign it to 1337. When I hit play, no errors. It just prints out that it's 1337, the last thing we assigned it to, which is crazy flexibility. Over in C#, we simply cannot do that. If we wanted to change the doit to be a like an integer, for example, we're simply just going to get an error saying that you cannot convert an integer into a bool. Once that variable has its data type, it cannot be changed. And this is probably one of the biggest differences between C# and Python at the fact of how they go about casting their data types. Next, I want to get into command terminations and the differences between C# and Python. First things first, what is a command? Well, for example, this bit of code here is a command. And what it's saying is take our doit variable and assign a false value to it. Same with up here, take our doit variable, assign a true value to it, and also cast it as a Boolean. These are examples of commands. So on a very low level, the way a computer works is that it needs to know when these commands begin and end, so it knows what it needs to process. And so that is where a command termination comes into play. We need something to be able to separate all these different commands. And in C#, the command termination is a semicolon. These semicolons right here is what you have to add to the end of every single command to be able to tell the computer that, hey, this command is over, you can process this before you process the next one. I'm grossly simplifying it, but that's how it works on a higher level. And so with that, in C#, so long as you have a semicolon separating your previous command from your next one, you can place your commands anywhere you want. For example, I can move this command right here to be right after the previous command. No errors, no issues. I can put it back on the next line and hit tab a bunch of times. No issues, no errors. You have a lot of flexibility using the semicolon as a command termination. C# has a lot of flexibility in this regard using the semicolon as a command termination. Now over in Python, they differ here a lot as well. So you might look at C# and see, okay, semicolon, that makes sense as a command termination, but Python, how do they do that? Well, the answer is quite simple actually. Instead of using semicolons, they just use a line break. So if you want to separate two commands, you just put it on a new line. Easy as that. In fact, to demonstrate, we can't do what we did over here in C#. If we were to put these right next to each other and then save it, you'll see that in the problems tab, it says that we have invalid syntax because it doesn't know what's going on here. Why is there a value and a variable after an assign? It just doesn't understand. However, Python kind of thought of all the stops. You can simply just add a semicolon and voila, it will now act as a command termination. In fact, just to prove that it does what I say it does, I'm going to bring them all in the same line, two command terminations, and then I'm going to press play and show you that it runs. It prints out 1337. So yeah, in this regard, this makes Python really, really flexible because you can use semicolons if you want to. However, you'll find that most developers don't because it's often a lot faster to just use the new line command termination instead of the semicolons. And allow me to demonstrate that. So I'm just going to restore both scripts to back how they were. This is a new line. This is a new line. This, I'm just going to do this. All right, so now they're back restored. So the reason why you can save a lot of time is because if you look at the two different scripts, they kind of both just use a new line termination anyway. Even if you were to look at more complex C# script, oftentimes you'll find that over 90% of a C# script is going to use like a new line as a command termination anyway. So you're actually saving a lot of time without having to type, semicolon, semicolon, semicolon. And you'll see that it turns red in this context because it's letting you know that it's pretty much useless. Like we know that you want to terminate this command by going to new line. And then if we were to hit a backspace, see it turns white because like, okay, now it's in use. We understand what you're trying to do here. But please note, this is a feature that comes with the Visual Studio Code IDE. So take that information as you want, but do know that most Python developers will probably look at you sideways if they see any semicolons in your code. So yeah, there are a couple of syntax differences there. Next, I want to go over how they differ in code blocking. So first question, what is code blocking? Well, I'm going to come up here in C# and give you a quick example. First and foremost, the way that you indicate a block of code is you use these braces. Anything that goes inside of these braces is a block of code. So the general syntax, you don't have to follow this, but most developers will put a block of code, one line in the middle is all the code that will be ran within that block of code, and then a brace at the end. And so here we can like just move our do it equals false into here, for example, and of course get rid of this one because we don't need it. And just like that, we have a block of code in C#. However, a block of code like this is pretty useless to add because it's going to be ran regardless. However, what blocking off code allows you to do is you can add things like, for example, an if statement. So we can say if do it, then set do it to equals false. And this block of code will only run if do it equals true. And I want to prove this to you. So I'm going to come up here and I'm going to write console.writeLine. This is just going to print anything that we want to the console. And I'm going to say checking. And then I'm going to come down here and then do it again. I'm going to say console.write. Oh, wait, what is that? Console.writeLine. There we go. I'm just going to set to false, right? And then at the end, we need a console.read key. This just makes sure that the terminal does not close when we hit the start button, which is up here, and I'm going to press. Boom. Terminal's off screen. I'm going to bring it up, and there we go. You see that it goes checking, and then it sets it to false. But you are not convinced because we blocked off this code and it still ran. So I'm going to change do it to equals false and watch what happens. When I hit the start button and bring the terminal over here, it just says checking because again, do it equals false. And we said if do it, which is another way of saying if do it equals true, then run this block of code. And at the fact that do it equals false, this block of code is never ran. And that's code blocking. You'll find that code blocking is very important and very useful for all things programming. But that's how you do it in C#. Now over in Python, it's again a lot different. I'm just going to get rid of these two lines just to make it a lot less confusing. And so everything under the condition and indented will be counted as that block of code. All right, now I'm going to run that and you will see that we get checking set to false. And then we also had an extra print down here that I'll remove next time, but that also prints out false as well. And again, you're not convinced because this block of code was ran anyway. So we're going to set this value to be false. And then I'm also going to remove this just so it's not confusing when it prints. And then save, hit play, and only checking. And so that is how you do code blocking in Python. And so, as you can see, code blocking is another syntax that C# and Python have a lot of differences between. But it's very important to know how to code block in both languages because you'll be using it quite a lot for loops, for if statements, for methods, functions, all types of stuff. And the very last thing that I want to go over today is what's called variable scoping. So what is variable scoping? Well, with the introduction to code blocking, that's this right here, a block of code. Remember, this is a block of code as well. Well, more right here, this is a block of code. But with the introduction to these blocks of code, now you have to worry about the scope of your variables. So let me give you a quick example. So let's say inside of this block of code here, we want to initialize a new variable. Let's initialize, just do an integer. We'll call it a just for an example, and then we'll assign a 0 value to it, right? Well, because we initialize this integer variable within this block of code, it cannot be used outside of this block of code. And to demonstrate, I'm going to come down here and I'm going to do outside of the block of code console.writeLine a, for example. And you can see what happens is it says that this variable does not exist. What do you mean it doesn't exist though? We initialized it here. Well, again, like I said, this variable, because we initialized it within this block of code, cannot leave this block of code. If we wanted to leave this block of code, we have to do it like this. We come out here, we come out here and we initialize int a equals, let's just say 5, for example. And then inside of this block of code, we just reassign it back to 0. So because it's initialized within this block of code, which is our main function, we can use it outside of this block of code. And that is variable scoping in a nutshell. Now over in C#, this syntax is no different. So if we were to come inside this block of code and initialize an a, assign a 0 to that, and then come outside of this block of code and try and print that a variable, you'll see that when we save and hit the play button, we get an error, syntax error, saying that this a, the variable a, is not defined. And again, if we want to get around this, we have to change the scope of the a variable. So come out to the regular indentation and just do a equals 5, for example. And then when we get into this scope, we're simply just going to reassign it, change it to 0, and then we'll be able to print it. And to prove that, I hit save and then I hit play, and there you go, checking 5. And again, just want to make sure I cover all bases. The reason why this prints out checking 5 is because we said do it to equals false. And if do it is true, then this block of code will be ran. But because do it is false, this block of code is not ran. So it just skips this entire thing and it just prints out 5, which is what we assign a to. And that's pretty much it. That is everything that you need to know to start programming in regards to the syntax. And so in conclusion, even though C# and Python have differences in their syntax, as you can see, the differences are small enough to be able to remember the important stuff. You have to cast data types in C#, Python you do not. In C# you must use semicolons to terminate commands, Python uses new line breaks. And C# uses curly braces for code blocking, while Python uses indentation. Of course, there are more differences in their syntax, but these are the major differences that often confuse new developers. All right. It's that time to code your first program. Are you ready to do this? Get set, let's go. So we're gonna make a simple MATLABS application in the console because it's simple, doesn't require you to install a million things, and is something you can actually show off to your friends and family. Now, before we jump into this, first things first, the code to this project is in the description. Also, I think it's important to let you know that this lesson is kind of acting as a placement test. If you're just beginning to program, you might struggle with understanding what's going on in the code. And if that is you, well, that's okay, because I structured this lesson to be just a little bit difficult to follow. Once you're able to code a project like this by yourself, then I don't think there's much this course can teach you at that point. But I encourage you to watch the whole thing and follow along anyway. Again, the code is in the description, so you can just refer to that and follow along with me. Because if you do the following, you will get the greatest inspiration to become a programmer. After you struggle, I encourage you to go through the rest of my course linked in the description, or just check out the lessons on the stuff that wasn't easy to follow. I have over 20 videos teaching you how to code, and those videos go in depth about their respective topics. Then, when you feel comfortable, come back to this lesson and see how well you do a second or third time coding your first project. And trust me, when you're able to look at how much you didn't understand in comparison to the next time you try and code your first project, you will not want to stop programming. Having programmed for 15 years, I can tell you that feeling pretty much summarizes programming very well. It can become quite addicting to chase, but an addiction in the best way possible. However, if this is your second or third or more times coding your first project, I encourage you to not copy the code verbatim, but maybe create your own story or add if statements and functions to this MATLABS game. Who knows? Your experimentation could start a whole new programming trend. Lastly, if you want to share your project with me, feel free to tweet it to me and I'd be happy to reply back to you. But now with all that stuff out the way, let's get started on coding your first program. And we're going to make this application in 2 different languages because I think it can be really helpful for you to see how they compare and contrast. And plus, you'll pretty much learn 2 languages at once. So on the left is the language C# using the IDE Visual Studio, which should interest you if you want to do Windows development or if you want to make games using one of the most popular game engines called Unity. And on the right is the language Python 3 using the IDE Visual Studio Code, which should interest you if you want to get into more general programming or data science. Alright, let's actually begin writing our MATLABS program. Now, before I write any project or program or prototype, what have you, I usually like to start what I like to call a skeleton. And what a skeleton is, it's pretty much just like a step-by-step process in which you can expect to have to do in order to complete the actual project. And because this is a smaller, simpler program, we can simply do this by writing out a few comments. So first I'm going to comment out initialize variables. Init just stands for initialize, it's shorter, quicker to write. And then after that, simply get input from user. So we're going to initialize the variables and then we're going to ask the user to fill out the data for those variables. And then after that, we need to initialize, init story. And then after we initialize our story, then we simply just need to print our story. And in 4 parts, our program will be done. Simple, easy, and to the point. And now let's just do that same thing in Python, do a comment, and then init variables, and then get input from user, and then after that we're going to init our story, and then after that we need to print story. Easy as that. Next thing I'm going to do real quick is just beautify our script. I'm just going to add spaces between all the comments. It just helps me read it and understand the different processes that need to take place. Perfect. All right, moving on. Now, before we can do anything over here, C# on the left, we kind of need our story because everything depends on our story, really. So I'm going to paste in a quote from the Matrix. I'm just going to highlight all this real quick and hit tab a couple of times to beautify it, make it easier for me to read. But you are welcome to make up your own story. You're welcome to grab anything from the internet. Whatever you want to use as your MATLAB story, that's completely fine. I even put this story in the description if you want to use it as well. But there we have it. This is the story that we're going to use for C#. And now I'm going to do the same for Python. Just paste in that story string, same exact thing, just in a Python format. Next thing you want to do is simply just print out our story. And in C#, you're going to want to do console.writeLine and then madlib story. Boom, semicolon, done. And in Python, we're going to want to, oh, wait, I'm going to change this to say madlib story just so that it's the same. Madlib story, perfect. And in Python, it's really simple. You simply just type print and then madlib story. Boom. So next what we want to do is get input from user. But we can't really get any input from the user because we have no variables to pass to the user to collect data from. And so what our next actual step is, we have to initialize our variables so that we can pass that to the user. And to initialize our variables, well, we need to turn our madlib story into a bunch of variables. And we can do that quite simply. If you're at all familiar with the game Mad Libs, then you know the whole fun of the game is that you have some story or some text or something like that, and you replace all of the verbs, the nouns, the adjectives, etc. with words that are similar context, hopefully, but not exactly. And it makes for like really funny, interesting stories. And so what we want to do is we want to scroll through our text and essentially replace verbs, nouns, adjectives with variables. And the first one I'm going to do is the matrix. I'm just going to put curly braces around this. Oh yeah, I need to make this into an interpolated string. I'm going to do that for all of these strings. And this needs to be a variable, which is one word, the matrix, boom. And so I'm simply just going to come to init variables. I'm going to initialize the string data type and put the matrix in there. And now the matrix is a variable that we can ask the user for, and they can change it to whatever they want. And I kind of did this ahead of time. I went through the text and picked a lot of verbs, nouns, adjectives that I thought would be interesting to change. So I'm just going to go through and do that. For example, system is another one. I'm going to change system into a variable. I'm just going to add that to this list. And I'm just going to do that for the entire text. I'm going to skip it though, because it's not that fun to watch. All right, so I went through my story and replaced all of the interesting verbs, nouns, adjectives, etc. with variables so that we can pass that to the user and they can put whatever words they want in there. But now I want to show you your first optimization trick. If you look at this line here, the sentence, it has businessmen, teachers, lawyers, carpenters. These are all professions. That's what they all have in common. And at the fact that they go back to back to back, we can do this really cool trick where we will initialize a string array. And we'll call them profession. And then, oh wait, I have to initialize it equals new string array of how many are there? 1, 2, 3, 4 of 4. And so now we can do this really cool trick where we come in here and just make this an interpolated string. And I'm going to lowercase that just for good practice. Businessmen. And, oops, sorry, that's not what I meant to do. I meant to do profession 0. Because we're going to do a for loop, which I'll get into in a second. I'm going to copy this because I am lazy. And I'm going to paste this here. And I'm going to increment it. And then I'm going to paste this here. And then I'm going to increment it to 2. And then the final profession, I'm going to increment this to 3. All arrays start on 0. Simple and to the point. And so now what we can do is when we get input from user, since there are 4 professions, they're all back to back, we can simply just write a simple for loop and ask the user for 4 different professions, one after another. And I'll show you how to do that in a bit. But there's also 2 adjectives down here that I also want to do this with. So I'm just going to initialize a new string array. Call this adjective, ADJ, short for adjective, equals new string array of 2. There's only 2 in there. And so here, turn this into an interpolated string. It's going to be ADJ0. And I'm going to copy this because I am lazy. And this is the second adjective. I'm just going to increment. And there you have it. We now have our 2 string arrays. And final note, if you look down here, you'll see a bunch of errors for unassigned local variables. And that's only because we have not assigned these variables to anything yet. I believe they're null at the moment, which your program does not like. But we will be assigning the variables when we get the input from user. And over in Python on the right, it's a lot of the same. First, let's turn all of our strings into interpolated strings. And it's just like C#, except it's an F instead of a $sign. So I'm just going to add an F to all of these strings. Perfect. And let's pop out this variable right here, the matrix, or rather, let's turn this into a variable. We'll call it the matrix. And then let's initialize it up here. I'm going to do the matrix equals empty string. All right. And then let's do system next. Interpolated string, system, and then system, I can just paste equals empty string. And I'm going to go through and do this for all the interesting verbs, adjectives, and nouns in this text. All right, so I pulled out all the interesting words and turned them into variables, and now I'm going to show you how to do that optimization trick over in Python. So again, we have these 4 professions, and we want to turn that into a string array. And to do that in Python, we're just going to do profession equals brackets, and there are 4 of them, so we're going to do empty string, empty string, empty string, empty string, 4 empty strings, and there we have an array with 4 strings in it that we can pass to the user, and then they can change to be whatever they want. And it's the same as C#. We're just going to use interpolated string, profession 0. I'm lazy, I'm going to copy this and paste it here, increment it, paste it here, increment it, paste it here, increment it. Oops, yeah, it is 3. And then we also want our adjective array, which is only 2. So we're going to do brackets, empty string, and then another empty string, 2 empty strings. And then that goes here, which is a adj 0. I'm going to copy this because I'm lazy, and then paste it on dependent, and then increment that, and bada boom. Now the scripts are in the same exact state. All right, the final stretch. Let's get that input from the user. So first of all, there are 2 functions that we need to familiarize ourselves with. One we've already went over, and that is console.writeLine. This is what we're going to use to print something to the console. And the second one is console.readLine. This is what we're going to use. Well, there's no input parameters, but this is going to return to us a string that we can set our string variables to. And this comes whatever the user types into the console, presses enter, that's what's going to be returned with console.readLine. So for example, we can do the matrix equals console.readLine. It's easy as that. So let's get started. I kind of ahead of time crafted a little interesting story that the user can have with the terminal just to make sure I'm not stumbling on this part. But let's start off with console.writeLine. Let's just do like welcome user. Welcome user, and then we can go down to another one, console.writeLine, and then let's say let's play a game of Mad Libs. And then after that we can get their name, so we can say let's do another console.writeLine, and then please share with me your name. And then here is where the terminal is going to stop and allow them to put in some input. So here we can do Neo, since that's the name of the character in the text, equals, and we can do console.readLine. And whatever they return here is what the variable neo is going to be set as. And just in case you don't believe me, let's actually run this program and see that being printed on the screen. First thing we need to do though is with all these errors, it won't allow us to actually run the program. So let's just comment out this entire thing. Whoops, hold on a second. I need to do that. I'm gonna comment this out, comment that one all the way down the line so this doesn't get compiled. And then let's replace this for now with neo. So whatever name that we pass to the terminal, it's just going to spit that right back at us, and that's going to prove to you that we're able to set variables this way. So I'm gonna come up here to the top and hit start, and my window actually goes out of frame. I'll bring it on screen. So as we put hello, welcome user, let's play a game of Mad Libs, share with me your name. And I'm going to put my name, Jabril's. Oh, of course it's going to exit because we also didn't tell it to pause. So let's, I think we can do console.wait for, no, let's just do another read key. Console.read key, that's going to wait for a key press, and then it's going to exit the terminal. So run it again, bring it back on screen. Welcome user, let's play a game of Mad Libs. Please share with us your name. I'm going to put Jabril's, and it prints right back to us the same variable that we put in, which is lets you know that it's actually working. So now I'm just going to revert back to its original state, and we can do Z, Control Z, Control Z, Control Z, Control Z, just a bunch of times. And we are back. Whoa, add semicolon. And we are back to our original state. And if you don't have Control Z, I think on Apple it's Apple Z, I believe. But if you don't have either of those buttons, you can come up to edit and then hit undo up here. And that will do the same thing that I did with my shortcut on the keyboard. Also, real quick, let's add at the very end of our process, let's add console.readKey. This will make sure that it pauses the application before it quits. Okay, so now over in Python, let's start to get input from users. So what we want to do here is instead of writing console.writeLine, again, it's as simple as print. And we can do print, welcome user, come down to another print. Let's play a game of Mad Libs. And then another print and say, please share with me your name. And then we can simply do neo equals input. Well, technically, we can add this string into input and it'll be the same exact thing. So we can do this, and it will print, and then whatever the next line is, it will get that input. However, we do need to add a line break here. Otherwise, it's going to allow you to type right after the question mark. We want to go to a new line just to make it a bit more cleaner. And so now the cool thing is, now that we have our actual name set in the variable neo, we can use that with our printing function. So if we do console.writeLine, for example, let's interpolate the string and do hello, and then we can do here neo, and then exclamation point, and then let's say something like are you ready? Are you ready? And then what is something you want to know more? Oh, running out of space. So I'm gonna go to next line. More about. You learn how to spell more about. And then next line, when they answer what they want to know more about, we can put that into the matrix. So, oh, I forgot my semicolon. So we can do the matrix equals console.readLine. Easy as that. And over in Python, it's pretty much the same exact deal. We'll do print. What is it? We need to interpolate the string with f. Hello. and then this will be neo. Whoops, neo, and then are you ready? Are you ready? And then actually I'm going to break this off. Whoops, I'm going to break this off into another print. Well, actually, I'm going to make this an input. Input, and then this is what is something you want to know, to know more about. And of course, we need to do the matrix variable equals whatever they want to know more about. So just to make sure that you're still with me, just remember that the only thing we're currently working on is get input from user. That's this section right here. Everything else we are not focused on. And within this section, there are only two functions that we're using. The first one is console.readLine, which is just simply printing some string to the user. And the second is console.readLine, which will return to us whatever that user inputted into their console that we can then assign a variable to it. That's it. Nothing more complex than that. So continuing along with our little storytelling, we can have a little fun and do console.writeLine and then interpolated string and do something like ooh, and then we can put you want to know more about, and then the matrix, huh? You know, just have fun with it. And then we can do another line, console.writeLine, interpolated string. Let's see. Next, what we want to do is we want to get the variable system. And so we need to give them a bit of a context. So we can do something like first, let's see, first, okay, please bear with me. Okay, well, first, tell me what you already know about the matrix. And then let's do one final one, which gives them a bit of instruction, because this is Mad Libs after all. We're gonna do, let's see, what noun would you categorize the matrix as? And then we can add like a little semicolon here. And then finally, we can do system equals console.readLine. And yeah, pretty straightforward. Again, I'm just trying to have fun with this Mad Libs as we're getting the data, the information, the input from the user. And so, you know, you also want to give, you know, this is just all Mad Libs clues right now, but you also want to give the user like some sort of hint as to what word they're replacing. So I simply just asked, what noun would you categorize the matrix as? And yeah, just trying to have fun with it. Over in Python, not much really changes. We're just going to print out the same exact strings. So ooh, oh, you want to know more about, and then we can put the matrix, huh? And then print another line. And this is going to say, okay, well, first, tell me what you already know about the matrix. Do another line. We're going to do F, and then what noun would you categorize the matrix as? Actually, I forget this is Python, so we can actually make this our input and then do system equals this input. And just to prove to you that we're just trying to craft a story here, nothing more complex than that. I'm going to initialize all of these remaining variables as empty strings, just so that that error clears up. Equals empty string, equals empty string, equals empty string, equals empty string. And now we can actually print out this story, even though most of the words, most of the variables are going to be, oops, equals empty string, are going to be empty strings. We can print this out. My console goes over to the left. So what is my name? Jabrils. And then as we wrote, hello, Jabrils, give us our name. Are you ready? What is something you want to know more about? There's a typo there. We can fix that. I want to know more about pizza, for example. Oh, you want to know more about pizza, huh? Okay. Well, first, tell me what you already know about pizza. What noun would you categorize pizza as? I categorize pizza as pie. And then that's as far as we got in our code. So now it does the Mad Libs. It replaces the variables within the actual Mad Lib story, and it gives us this. Pizza is a pie, Jabrils. That pie is our, and then it's all empty strings from there. But as you see, this is all we're doing at the moment, is this part of the terminal script. We're just crafting the story. That's all that's to it. Hopefully at this point, I've convinced you that we aren't doing anything complex with this stage. We're just printing out a story to the console and asking for variables. That's all. So let's just finish off our story by moving on. So next thing that I want to do here is, of course, we're going to do console.writeLine, and we're going to interpolate a string. And what I want to put next is, let's see. Give me an opposing noun to system, right? Because the next word we're going to get is enemy. We're going to try and replace enemy. And again, we're just trying to give them some sort of hint for a good noun to replace. So that should work. So then we're going to do enemy equals console.readLine. All right. So hopefully this string that I'm printing to the console is enough to give them a hint on a good word to replace enemy with. Moving on, we're going to do another console.writeLine. And what are we getting next? Next, we are going to get the word inside. So let's see. What hint can I give for inside? I don't know. Relaxing noun. Let's say now give me any relaxing noun. And of course, this needs to be in the present tense. Present tense. And then we can do inside equals console.readLine again. And we just keep on going down the line. We're now going to get caught up to speed in Python. So last left off with system. So we need to print, let's see, interpolate a string. Let's do, what is it? Give me an opposing noun to system. And I always forget, this is Python, so we don't have to print and then do a read line. We can just do input. Let's see, what's the variable's enemy, right? Yeah, enemy equals input. Cool. And then we can do the same thing with inside equals input. And then I'm going to interpolate the string. And then let's do now give me any relaxing noun. Present tense. All right. Oops, no semicolon, not in Python. Cool. And we are all caught up. Now, next up is the interesting part that we kind of set up a little earlier in the video. Now we need to actually use our for loop for our string arrays. And so we can go about doing that really simply. Just create a for loop for int of I equals 0. I is less than profession dot length. semicolon I plus plus. And then come down here, start our brackets. And so this for loop is just going to go through the professions, which is next up in the text prompt. And we can simply just ask, let's see. I guess before that, though, we need to alert the user, say console.writeLine, and say, okay, now I need 4 professions relating to, what is this? Relating to system, and then interpolate the string here. Boom. So we alert the user what's about to happen. I need 4 professions relating to systems, and then here we can do console.writeLine, and we're going to do a course interpolated string here, and let's do profession. If I have any typos, I apologize. Profession plural, because again, we're doing businessmen. I don't remember them originally, businessmen, accountants, something like that, but they're in a plural. And then we can just simply let them know where they're at by doing I plus 1, because I is going to be 0, starts at 0, so we can do that, plus 1 to get it started at 1, and then simply profession.length. Right, so what this does, let me just walk you through this. I think I was a bit vague. So what this does, simply, as we're going through our for loop, there are 4 different professions. It's going to write to the console, give me a profession, plural, and it's going to print out what number profession they're currently filling out. That's all it is. And then it's divided by the length is how many professions we need. And I'll show you this example a bit later. But once we do that, then after every single time we print that to the console, we want to read line and assign profession of I to that. And that will pretty much populate our entire profession string array. All right, and to get caught up in Python, it's not too difficult. Of course, we need to write out our print, and we are currently alerting the player that a for loop is about to happen for the most part. So, okay, now I need 4 professions relating to system, right? And then we got to do our for loop. And for loops in Python they're a bit different. So we're going to do for I in range length of profession. And then we'll do our colon, and the next line we'll do profession of I equals input. And then here, what do we put? We put profession, which is definitely a typo in the C#. Profession, and then plural. And then here we want to do I plus 1. Oh, this is not an interpolated string. Gonna add an F to make it an interpolated string. Divided by length. Oops. Come on. There it is. Length of profession. And there we have it. They are now currently up to speed. Now at this point, I'm pretty sure that you could finish this program on your own, because we're just essentially going to do the same exact stuff we've been doing. And once you fill out the remainder, what is it, like 3 or 4 variables, the application's done. However, I want to take a second to pause, because I often don't go this long without leaving comments. It's always nice to leave comments for yourself in the future, or if you're going to send this off to a friend, or if you're going to upload it to GitHub for, other developers to try and take apart and learn from. It's always good and nice to leave comments. So let's do that. Just to explain what's happening here, I'm just going to say we are getting the matrix variable variable from user. It's going to be a lot of those comments. Getting system variable from user. Getting enemy variable from user. Wait, I didn't even add system variable from user, sorry. Getting, what is this, inside variable from user. And then this is, I'm just gonna say commencing for loop. No, wait, commencing, no, I'm not even gonna say that. I'm gonna say getting all professions from user. Also, I know that I have a typo here, so I'm gonna fix that. Profession, yes. Cool. I'm actually gonna combine these. No, I'm not. And yeah, this really helps me out personally. Oftentimes when I'm reading code, I'll often look for the green, or like where the comments are, whatever color the comments are in the language. I often look for those as like kind of like markers, so I can kind of fill out the code and know exactly what's going on where. So it's always good practice to leave comments. In Python, we're gonna do the exact same. I'm gonna leave a comment here, getting the matrix variable from user. I apologize if I have typos. I'm not terribly concerned about that. Getting system variable from user, and then this is going to be getting enemy variable from user, and this is getting inside variable from user, and this is getting all profession variable from user. I'm also going to change this profession. I guess that doesn't really matter. Cool. A bit redundant, but it always helps. All right, so I went and did you a favor and pretty much wrote out the rest of the logic for the rest of the variables, because it probably would have got a bit too mundane if I were to record it on screen, but we can walk through it anyway. So right after the professions for loop, we are essentially getting the save variable, and we do that by writing to the console, give me a hero related verb in the present tense. Again, this is just hints for the user so they kind of have an idea on what word they're replacing, and then we will save whatever string they return to us into the save variable, and then we get the unplugged variable, which we do that by writing to the console. Now give me a verb that makes you think about relief in the past tense. Again, just another hint. You can see how mundane it probably would have been. And then whatever string they return to us with console.readline, we will save that into the unplugged variable. And then after that, we need to get our adjectives. There are two of them. So we first warn the user, say, lastly, I need two dystopian adjectives. And then we do a for loop. And simply, we will tell them that they are currently filling out an adjective, and we'll let them know what number they're on out of the total number, and then we will save that to their respective adjective variables, whatever string they return to us. And then lastly, we just need to get the fight variable, and we just say, hey, we need a verb on the console, and then whatever string they return to us, we will save that into the fight variable. And that's pretty much it. On the Python side of things, it's the exact same, just in Python syntax. You know, get the save variable, get the unplugged variable, get the two adjectives, do a for loop, and then get the fight variable, and we're done. Great work, guys. Our Mad Libs application is pretty much done. I mean, there's nothing left to do, except there's one thing that I want to do on Python. So the input function is a bit different than the console.readline. The console.readline function will always go to a new line. The input does not. So with that, let's kind of format this a bit. I'm going to do, with all the inputs, semicolon and then a space. So whatever question we ask them, they can input that right after our question. So I'm going to do that again. I'm actually going to remove the question mark because it might get a bit confusing with that syntax anymore. So this, I'm going to add a space there, and then input here, I'll do colon space. Here I'll do colon space. Where else? Here I'll do colon space, and this is the input space. This is input space. Here space, input here, space, and boom. All right, and that's just going to look a lot more cleaner when we're actually playing the game in the terminal. So all that's left is to play it. Let's actually play it. I'm going to run C# first. I'm going to bring this over here, and it says, "Welcome, user. Let's play a game of Mad Libs. Please share with me your name." My name is Jabrils. Hello, Jabrils. Are you ready? What is something you want to know more about? I want to know more about pizza. Oh, you want to know more about pizza, huh? Okay, well, first, tell me what you already know about pizza. What noun would you categorize pizza as? I'd say pizza is a pie. Give me an opposing noun to pie. Maybe cake. Now give us a relaxing noun, present tense. I guess sleeping is a relaxing noun in present tense. Okay, now I need 4 professions relating to pie. Ooh, I don't know, baker, cook, chef, I don't know. I don't know. What's the last one? I'm just gonna say butcher. I don't know. Give me a hero-related verb in present tense. Hero-related verb in present tense. Let's see. Save. That's all I can think of. I know that's the actual word, but it's all I can think of. Now give me a verb that makes you think about relief. Massage. Massage in past tense. Massaged. Yeah. Is that a verb? Something you do? I guess. I don't know. Lastly, I need 2 dystopian adjectives. Describing words. I don't know. Burnt, I guess. And what's another one? Dirty. I don't know. And a verb. A verb is what you do. Let's say what you do. Kick. Let's see what we got here. Pizza is a pie, Jabrils. That pie is our cake. But when you're sleeping, you look around, what do you see? Baker, cook, chef, butcher. Oops, I didn't listen to instructions. It's supposed to be plural. Very minds of the people we are trying to save. But until we do, these people are still a part of that pie, and that makes them our cake. Very deep. You have to understand, most of these people are not ready to be massaged. And many of them are so burnt, so helplessly dirty on the pie that they will kick to protect it. Art. Absolute art. And now let's play it in Python. Real quick, not sure how I missed this, but we need to put input at the bottom so the console will stay open. But it's a bit different to actually play it with Python. Go up to here up the top where your project file name is, right click, and then do reveal and explore. And then wherever your file is, just double click it and a terminal should pop up. It should look pretty much the exact same, just with the slight Python syntax difference that we did. And so please share with me your name. My name is, what am I going to say? My name is Vegeta. I'm cool this time. Hello, Vegeta. Are you ready? What is something you want to know more about? I want to know more about, let's see, not pizza. I want to know more about Skittles. Skittles, huh? Okay, well, first tell me what you already know about Skittles. What noun would you categorize Skittles as? I'd say it's candy. Give me an opposing noun to candy. Ooh, veggies. Now give me any relaxing noun in the present tense. Relaxing noun, person, place, or thing. That's actually probably incorrect, but I'd understand when it's asking. Relaxing noun, I don't know. relaxing itself. Okay, so now I need 4 professions relating to candy. Let's see. Baker. Clerk. I don't know. It's supposed to be plural. I keep forgetting it's supposed to be plural. Clerks. Baker. I don't know. What do you call a candy maker? I'm looking. Candy makers. Candy makers. Chocolate factory owners. Let's see. Give me a hero relating verb in the present tense. What do heroes do? They save. They fight crime. Verb fight crime. Fight crime. I don't know. Now give me a verb that makes you think about relief. Coding. That's what you do in past tense. Coded. Lastly, I need 2 dystopian. Let's do dystopian. Let's do empty, I guess, and let's do dark. And a verb. Slide. Let's see what we got here. Skittles is a candy, Vegeta. That candy is our veggies. But when you're relaxing, you look around, what do you see? Bakers, clerks, candy makers, chocolate factory owners, the very minds of people we are trying to fight crime. But until we do, these people are still a part of that candy, and that makes them our veggies. Very deep. That is so deep. You have to understand, most of these people are not ready to be coded, and many of them are so empty, so hopelessly dark on the candy that they will slide to protect it. Wow. Wow, so deep. That's poetry. And there you have it, guys. Congratulations on creating your first ever program. You did it. Congrats, everyone. Believe it or not, you've just written an actual usable program. You can go right now and play this with your friends and loved ones and impress them with your new skills. But if you're still lost, you should feel really lucky, because this video is part of a programming course that I put together to teach you everything that you need to know to start programming. And I promise by the end of it, this application will be very easy for you to understand, even without my help. I envy all the knowledge that you get to learn. So maybe there's some things that you understood and others that confused you. Well, I designed this course that you only have to take the lessons that you want to take. No prior lessons required. Make your own curriculum. So, what are you waiting for? Now, if you want to be a good programmer, it's very important that you get a solid understanding on data types. So, let's talk a bit about them and get you familiar with the basics of them. On the most fundamental level, let's say you have some data that is stored in a variable. Well, this data has some sort of type that's associated with it. There are a good number of different data types, and they all have different instructions and rules. And this is so your computer knows what it can and can't do with the variable. Now, there are 6 main data types that are shared across most languages. Bool, which stands for Boolean, named after the 19th century mathematician George Bool, whose work popularized it. Char, which stands for character. String, which stands for string of characters. Int, which stands for integer. Float, which stands for floating point value. And array, which isn't actually a type of data, it's a data structure, but by definition, it's an ordered series or an arrangement of similar types of data. And note, there are more data types that exist out there, but if you want to learn more about these in particular, I have a lesson on each and every one of them. Check the link in the description because this lesson will only briefly go over them. Now, again, every single one of these have their own unique set of rules and instructions. For instance, let's take a look at the integer data type, which are a type of data for whole numbers. Let's say that you have an integer that equals 11, and you want to minus 1 from it. Well, you'd write out this operation, send it to the computer to perform, and guess what? Your computer would take a look at this operation, then we'll look to see if it has the instructions for doing that operation. Then we'll go, yeah, I know how to subtract an integer from an integer. The computer will then subtract 1 from 11, and then send back to you a 10. All well and good. everything checks out. But now let's take a look at a string data type, which again is a string of characters. If you were to have the string 11 and you wanted to subtract the integer 1 from the string 11, well, you send this operation to your computer would take a look at this operation, then check to see if it has instructions on how to do that or not. Then it would realize what you sent it makes absolutely no sense. It has no instructions on how to subtract integers from strings. This is no different from telling your computer to subtract 1 from the word hello. How do you do that? So your computer will just send back to an error, letting you know that the operation you're trying to do makes no sense, which specifically in this case is a type error. Now let's do the same operation, but instead make both of them strings. What do you think will happen? Will we get a 10 again, but as a string? Maybe we'll get another error. Well, if you again have the string 11 and you send the operation to your computer to subtract the string 1 from the string 11, your computer will look at this operation, then again realize it has no instructions on how to do this, thus returning back to you an error. But you may find this next part quite interesting. If you instead tell your computer to take the string 11 and plus the string 1 to it, it will look at this operation, then check to see if it has any instructions on how to do this or not, and then say, yeah, actually I can do that for you. Then it'll send back to you a string of 111. Simply because since the string 1 and the string 11 are both strings, all it has to do is add an extra 1 to the 11 string. Just for example. And there you have it for data types. That is why understanding data types is really important. You will have a very hard time trying to write programs without knowing the difference between a number as an int, float, or string. Check out the lessons linked in the description to learn more about each data type individually. But in conclusion, just remember that data types are different types of data with different rules and instructions. And depending on the data type of your variable, there are certain operations that you can and can't do with it, which will become very important to grasp and understand as you start using them. So let's talk about bools. Bool is short for Boolean. If you hear bool or Boolean, they mean the same exact thing. And it was introduced by George Bool in his book, The Mathematical Analysis of Logic in 1847. But what is a Boolean in terms of programming? Well, a Boolean is a data type that can only be assigned one of two different values, either a true value or false value. And that's it. It honestly doesn't get any more complex than that. And what might take you by surprise is that Booleans are the most fundamental building block for programming. Most of your code will simply just check if something is true or not, and complexity is added by combining a bunch of Booleans. But we'll get into that in just a bit. But for now, let's get into the nitty-gritty on how you go about using Booleans. And we're going to do this by using two different languages, because I think it can be really helpful for you to learn how they compare and contrast, and plus, you'll pretty much learn two languages at once. So on the left is the language C# using the IDE Visual Studio, which should interest you if you want to do Windows development, or if you want to make games using a popular game engine called Unity. And on the right is the language Python 3 using the IDE Visual Studio Code, which should interest you if you want to get into general programming or data science. Alright, so here I have two brand new console projects, and if you don't know how to make a new console project in either C# or Python or both, be sure to check out the video in the description. It's called How to Install an IDE, and at the end of that video I'll show you how to do that. Alright, so the first thing I want to get into today is just some basic Boolean syntax. So first thing I'm going to do is just delete these two lines, don't need them, they come standard with every new C# project. And then I'm going to cast a Boolean data type, bool, and then I'm going to create a variable called pizza time, then I'm going to assign it to be true. Now, the first thing that you need to know about Booleans is that they only have two states. They can either be true or they can be false. That is about the only flexibility that a Boolean has when it comes to assigning it. But over in Python, Booleans have just a little bit more flexibility. So I'm going to create a new variable. I'm going to call it pizza time, of course. Then I'm going to assign a true value to it. And now it knows that this is a Boolean. But I can also assign a false value to it, or I can also assign a 1 value to it. That equals true. And lastly, I can assign a 0 value to it, and that equals false. And just to prove it to you, I'm going to show you all the different cases. So we'll do true here. And then to check it, we need an if statement. So I'm going to say if pizza time, then we need to print pizza. Oh wait, I meant a string. pizza, like that. I'm going to hit the play button and you will see that it prints out pizza. Next, I'm going to change this to false value and it should print out nothing. If we hit the play button, you see nothing was printed, just as we expected. And now I'm going to change this to be a 1 value and hit the play button. You'll see that again, we get pizza. Pretty nice. And lastly, I'm just going to say pizza time equals 0, save it, hit the play button, and you see that we get nothing printed. So what's going on here? Because clearly the pizza time variable is an integer, and we're saying if 0, then print pizza time. That doesn't make any sense, right? And that's one of the benefits to Python being an interpreted language. It allows you to pass in integers in a conditional statement, and if it's a 0, then it's going to convert that into a false value, but if it's 1, it's going to convert that into a true value. In fact, any numeric value that is not a 0 and it's being used as a conditional statement will return a true value. So, pizza time equals 9, save, hit play, you'll see that it prints out pizza. Pizza time equals -3, hit save, hit play, still prints out pizza. This isn't only limited to integers. You can also use floats. So if we say pizza time equals 0.00000001, hit save, you'll see here pizza time is now a float. We hit play and still it will print out pizza. And this is unique to Python. We can't even think to do that in C#. If we were to even try it, we get all sorts of errors. So that's just one extra flexibility that you have with using the language Python. Font increase. So now I want to get into the many operators that Booleans have, which is just a testament to how powerful these things are. But let's start with the equality operator. Now, let's say that you want to create some like user login system, right? So I'm just going to create a couple of strings here. I'm going to say string password typed. PT stands for password typed. I'm going to say equals ABC123. And then let's do another string, semicolon, of course, and then do another string. And this is going to be PA for password actual. And we're going to say equals, again, ABC123. Okay, so let's say that this is the user's actual password, PA, ABC123, and what they typed is ABC123. So how can we check to see if they match? Well, we'd have to use something that's called the equality equal operator. And the equality equal operator looks like this. PT equals PA. And that's all that's to it. Now, I know what you're thinking. This looks really confusing. And I've been programming for about 13 years now, and I agree with you. So one thing that I usually like to do with my Booleans is, first and foremost, I like to put parentheses around whatever is like the Boolean that I'm checking for. It just makes it a lot easier to read when I'm scanning lines of code. But to explain to you what's going on here, again, equals equals, that's two equals back to back, is what we call an equality equals operator. Do not get it confused with one equal. One equal is simply just the assignment operator. It means that you want to assign something to a variable. Two equals, again, is checking if two things equal each other. So if we were to read this full line, we're simply just initializing a Boolean variable called pizza time, and we're assigning the value true or false to it with this Boolean operation here. And what this Boolean operation simply does is it just checks if PT is equal to PA. If it is, then pizza time will equal true. But if it's not, it's going to return a false, and pizza time will equal false. I mean, pretty simple, right? We just ask if two things equal each other. If it is, then give us a true. If it doesn't, give us a false. And as simple as this is, if you've ever logged into anything before, this is pretty much all they're doing, with maybe a couple extra checks on top of that. All right, I think I beat that horse well enough, but I keep on hammering this in because it's really important that you understand this step. If you understand what's going on here, then I think a lot of programming is going to be really easy for you to understand, because this is like one of the staples to programming. Moving on, just to prove to you that this works as I am saying that it does, we're going to come down here and do a console.writeLine. Just print this to the console, pizza time. And then we also need a console.read key. This just makes sure that the console doesn't immediately close when we run it. Hit the start button up here, and then I'm going to bring the console on screen, and as you can see, it returns a true value. But if we make one of these slightly off, if I turn this to be 1, 2, 4 instead, and we hit the start button, you can see that what it returns to us is a false value. So it is not pizza time because they do not match. They are not equal. And now over in Python, I'm just going to quickly recreate the same scenario. Pizza time equals, well, we need something before that. We need pt equals abc 1, 2, 3 pa equals a string abc 1, 2, 3, and then pizza time equals pt equals pa, like that. Going to add the print. Let's do print pizza time here. And then I'm going to hit the play button and returns a true value. Perfect. And of course, I can make one of these slightly off and then hit the play button and returns a false value. Now, I really hope that all that made sense, because if it did, everything from this point on is going to be really easy to understand. But next, let's move on to our next operator, which is the equality not equal operator. And how the equality not equal operator works is, let's say that you want to check for like some bad word, right? So we're going to change PA to be bad word, right? And so instead of checking if they are the same, you're going to check if they are not the same. And not is going to be indicated by a exclamation point. Now, what this is saying is, if they do not equal each other, then I want you to return a true value. However, if they do equal each other, then I want you to return a false value. It pretty much just flips the Boolean operation, which again is what we want in this scenario, because we're trying to filter out bad word. If what you typed is bad word, then it's not pizza time. And just to prove to you that this will return a true because they do not equal each other, I'm just going to hit the play button up here and then bring the console on screen. You can see that it returns a true value. So that's pretty much everything that you need to know about the equality operators. Next, let's get into the relation operator, starting with the greater than operator. So imagine that you have some login system and you want to limit the amount of times that a user can log in. Well, one thing you can do is use one of the relation operators. Let's just start with the greater than. So first thing, let's just ignore these two variables for now and create new ones. We're going to make an integer. I'm going to call it log attempt equals, let's just say it's 3. And then let's make another integer and call it log max equals 5, for instance, right? So what we can do is come down to our pizza time boolean, and we can replace this with log max is greater than log attempt. And what this is doing is it's essentially checking if log max is greater than log attempt. And seeing as log max is 5 and log attempt is 3, this is going to return a true value for our pizza time boolean variable. And just to prove to you that this is correct, I'm going to hit the start button, bring the console over. You can see that we have a true value. So that's the greater than operator. We could also use the less than operator, which is going to check if log max is less than log attempts, return a true value if that is true, a false value if that is false. But there is also a greater than equals to operator, which just checks both if it's either greater than or equal to the log attempts. And then finally, of course, there is the less than and equal to operator that will check if log max is less than or equal to log attempt. And over in Python, these operators don't change at all. I'm just going to get up to speed. I'm going to do log attempt equals 3, and then log max equals 5, and then come down to our pizza time boolean and do log max is greater than log attempt, and then I'm going to run that just to prove this works the same, and voila. And the last operators I want to go over are the and or operators. So here is where you're really going to be able to see the power of booleans being demonstrated. All right, so let's bring back our old scenario. So we're going to change this back to ABC123 for our past actual, and then our past typed is also ABC123. And let's replace this boolean operation with PT equals equals. That is our equality equal operator equals PA. So what if you wanted to check if the password is a match and they're under a certain number of login attempts? Well, we can use our AND operator. And in C#, it's done like this. You just type the AND ampersand and then another AND ampersand. And that is the AND operator. And then after that, you can write out another Boolean operation. So we're going to write log attempt is less than log max. And so what this full Boolean is asking, it's just pretty much asking, do our password typed and our password actual, do they match? And the two AND ampersands, and are we under, our log attempts less than our log max? If true, if both of these are true, then return a true value for our pizza time. But if either of them are false, doesn't matter which one, then return a false value for our pizza time. And just to prove to you that that is how this operation is done, I'm going to press the start button on the top and bring the console window open. You can see that we have a true value here. And all it takes is for one of these to be false. And I'm just going to change this to be ABC124, and then I'm going to hit save, and then I'm going to hit the start button and bring the console window over here, and you can see that we have a false. Even though one is true, we're asking for an AND. That means they both have to be true in order for pizza time to be true. And just a quick side note, I generally like to use a lot of parentheses, as many as possible when it comes to Boolean operations like this, like the segment, because it just makes it a lot easier for me to read when I'm just going through lines of code. Parentheses let me know, okay, there's a Boolean operation here. I see the AND, I know there's another one. It just makes it a lot easier for me. And even sometimes I'll do like an overall parentheses over the entire Boolean operation. It just helps me read it a lot easier. I don't know if it helps you or not, but that's a tip that you could use. And over in Python, the syntax is just a little different. So I'm just going to get caught up to speed. Going to change this back to pass 1, 2, 3. Oops, that's not pass, is it? That's ABC 1, 2, 3. Sorry, ABC 1, 2, 3, and then we change this to be PT equals PA. Why did you not IntelliSense for me? And the way that we do an AND in Python is you literally just type out the word AND. And log attempt is less than log max. Boy, that has became a really small window. Maybe I should zoom out just a bit. Cool. So now I'm just going to prove this by hitting the play button, and you can see we got a true value. But yet again, all it takes is one of these Boolean operations to be false, and the entire thing becomes false. And I'm proving that by changing this to 4, hitting the play button, and we got a false value returned to us. But what if you wanted to be a merciful social media developer, right? Where you don't care if they get one or the other wrong, as long as they get one of them wrong. First of all, don't ever do this. But if you wanted to do this, you would simply just change the AND operator into an OR operator. And in C#, this is done by replacing the 2 ampersands with 2 vertical lines. I'm not sure what these characters are called, but you replace it with 2 vertical lines. It's on the same key that the / key is on. Just looked it up. I guess it's called the vertical bar character. Never knew that. But anyhow, this will now check if either of them are true, which we know that one of them is false because PT does not equal PA. But the second one is true because log attempts is less than the log max. And to prove that this will return true because one of them is true, I'm going to hit the start button and then bring the window over. You can see that we have a true value returned. And over in Python, the OR operator is just a bit different. Just as you write out AND for the AND operator in Python, you have to write out OR for the OR operator in Python. And now over in Python, the OR operator is just a bit different. Just like how you had to write out AND for the AND operator, you have to write out OR for the OR operator in Python. And of course, just to prove that this works, I'm going to hit the play button up here, and you'll see we get a true value returned. So I hope you can see what makes Booleans so powerful in the world of programming. Just from this simple example alone, we already have a Boolean that checks for the log attempts next to, the actual password typed. And then we can take this Boolean and embed that into another Boolean and just keep on adding complexity and complexity. Booleans are incredibly powerful and they're really important to understand. And yeah, there you have it, guys. That is pretty much everything that you need to get started programming in regards to Booleans. So, strings. Strings are one of the most important ingredients to almost every program you'll ever make. Why? Well, the odds are likely that at some point in deployment, or even during development, some human will have to interface with your application. And with that, your program needs to communicate with them somehow. And it's highly likely that using strings will be how you go about doing that. Strings, on the most basic level, are a string of characters together in a series, hence the name string. You can write any word in any language. You can write any number or even any code, slang, key, you name it, making strings incredibly powerful. And that's pretty much all that's to strings. They're really easy to get your head around. And there are a few things that are really good to know while using them, so let's take a look at a few examples. Now, we're going to do these examples using two different languages because I think it can be really helpful for you to see how they compare and contrast. And plus, you'll pretty much learn two languages at once. So on the left is the language C# using the IDE Visual Studio, which should interest you if you want to do Windows development or if you want to make games using a popular game engine called Unity. And on the right is the language Python 3 using the IDE Visual Studio Code, which should interest you if you want to get into more general programming or data science. Alright, so here I have two brand new console projects. And if you don't know how to make a new console project in either C# or Python or both, be sure to check out the video in the description. It's called How to Install an IDE, and at the end of that video I'll show you how to do that. Alright, so the first thing I want to get into is some basic string syntax. So first I'm just going to delete these lines. They come stock with your brand new C# project. And then I'm going to initialize a string. I'm going to call it A just for example. And then if you want to assign a value to a string, you have to use double quotes, and then you can type in whatever string you want and then semicolon at the end. And as far as C# string syntax is concerned, that's all you really need to worry about. It's just the double quotes. Make sure they are double quotes. Now over in Python, we have just a little bit more freedom. So I'm going to initialize a string here, and then I'm going to assign hello to it. And as you can see, I use the double quotes just like we did in C#, but you can also initialize a string and assign hello with the single quotes as well. Both of these will be counted as a string within Python. And just to prove that, I'm going to do print A and then B. Here we go. And there you have it. Hello and hello. Both are counted as strings. In fact, today you're going to find that this freedom right here, the double quotes and the single quotes, can be assigned to a string, is quite nice. You'll see. And so the next thing I want to talk about is the fact that strings are arrays of characters. And to demonstrate that in C# over here on the left, we're simply just going to do a console.writeLine. And then I'm going to do A, and then I'm going to use the brackets and just put a 0 in between them. This is an element within the A array. Again, strings are an array of characters. So I'm just asking for the 0th element from the A string array, which this is 0, this is 1, this is 2, 3, 4. Arrays always start on 0 in pretty much every programming language. And so now just to prove that, I'm going to hit the start button up here to run it. And I always forget. I have to do console.read key. This just makes sure that the terminal stays open until we press a key. I'm going to hit start, and then bring this over here, and you see that we have the 0th element in the A array, that is again a string of characters, which is H. And it's quite flexible. We can put any that we want in here. Let's do exercise. So if we want to get 0, we can simply count. This is 0, and then E is 1, 2, 3, 4. So if we put 4 in here, then when we hit the start button, you'll see that it prints out an O. In fact, this technique is what a lot of game developers use when they're trying to create some chat system that pops up one character at a time. They'll pretty much write out the entire dialogue here, like hello, welcome to my store. And then they will write some function that will take in a string, and then we'll grab every single character, and then we'll print one out with a pause in there, like a second pause, probably a lot less than that, like a 1/10 of a second pause, then print the next one, 1/10 of a second pause, print the next one, so on and so forth. Just a little add-on there. And over in Python, I'm gonna get rid of the B. We're just gonna keep the double quotes convention to match with C#. Get rid of the B here. And then I'm actually just going to do a print. Let's do 0 first. Hit the play button, and you'll see we get an H. And again, we're going to do a 4 so we can get the O. Hit the play button, and oh, I forgot I got to save it. And then hit the play button, and then we have a O right there. Pretty much the same in both languages. Again, just remember that all strings are just an array of characters. Next thing I want to talk about is using the addition operator with strings. And to demonstrate that, over here in the left with C#, I'm just going to remove this back to how we had it. Remove this from the right. And I'm just going to come down here and do A plus equals, that's the addition operator. These two right here, when you see plus equals, that is an addition operator. Plus equals, and we just add a character exclamation mark to it. And then I'm going to print that. You'll just see that's going to be hello. And then they're just going to add a little exclamation at the end. Start that up, bring it over here, and voila. Now, one cool thing about this process is because at the fact that the string A is just an array of characters, using the addition operator pretty much just says, take that string of characters and add this character to the end of it. However, the cool thing is you aren't limited to only adding characters. Again, single quotes denotes a character, double quotes denotes a string. So we could add to the end of this world, for example. Now, of course, we have to change these single quotes to double quotes to let C# know that this is now a string. And what this is going to do is it's now going to add every single character in this character array, or this string. It's going to add every single character to this string. And just to prove that, I'm going to hit start, and then I'm going to bring this over, and voila, hello world. All right, now over in Python, I'm just going to restore this back to its original state. Then we do A plus equals exclamation mark. Now, of course, this is just going to take the hello string, the A string, add an exclamation point to it, and it's going to print that out. If we hit the play button to confirm, come down, and that is exactly what we got. Now, I want to again reiterate that Python doesn't care if you use double quotes or single quotes for characters or strings. So unlike C#, we could just put world right in between of two single quotes, and it will, when we hit play, it will print that out for us without giving us any errors or any problems whatsoever. That's just one of the benefits to using an interpreted language. If you want to use single quotes or double quotes, that's pretty much up to you, your own discretion. But just to keep everything consistent, we're going to use double quotes for strings as well for this lesson. Now, before we move on, you might be wondering, oh, well, if we can do an addition operator, what if we use like a multiplication operator or a subtraction operator or a division operator? Well, unfortunately, the addition operator is the only arithmetic operator that you can use on strings, so don't get too happy. Now, escape characters are actual characters, so I'm not going to go too deep into them for this lesson, but they're pretty important to strings, seeing as strings are an array of characters. But let's just look at a few of them real quick. So I'm just going to add a few of them here. I'm going to do \n, and then I'm going to do \t, I'm going to do single quote, backslash, double quote, and then backslash, backslash. Now these are, what is that, 5 of the most popular escape characters. The first one, this is new line, this is a tab, this is single quote, this is double quote, and this is backslash. And I'm going to just print it out just to show you that what they do. Hit the start button and then bring this over. And so you have a new line, which is the backslash n, and then a tab, which is backslash t, and then you have the single quote, which is backslash single quote, then you have double quote, which is backslash double quote, then you have backslash, which is backslash backslash. And these bad boys are handy because they help you do some things that are probably not intuitive when you first start coding. For example, like how do you press enter when you have just strings, or how do you use double quotes if strings require double quotes to initialize, right? So for example, I'm just going to get rid of all of these. Just to give you a quick example. I'm going to use the escape character double quote at the end and the escape character double quote at the beginning, and this is going to look like hello in quotes. I'm gonna hit the start button and then bring this over, and there you go. You have escaped the syntax of strings by using the escape character. Again, I went over this pretty briefly in this lesson, but if you want to know more about that, check out the lesson I did on characters, and I go a bit more in depth about them. So I'm just going to restore this back to how it was before I move on to Python. Now over in Python, the syntax for the escape characters are the exact same. I'm just going to get rid of this line and then just add them just as we have in C#. Backslash T, backslash single quote, backslash double quote, and then backslash backslash. Make sure to add that double quote back. And yeah, there you have it. One cool thing about this is actually a Visual Studio Code edition is that it will change the color of the escape characters in your strings. That's pretty handy. I'm just going to print that out. We should get similar results. And there you have it. All right, so the next thing I want to get into is interpolated strings. Now, there is no reason for a man to have so much love for a syntax, but I absolutely love interpolated strings. And here you'll love it too. Here's what's going on. Okay, so say we wanted to deliver some message, right? I'm gonna get rid of all of this and do like hello name, how are you, right? Now let's say you didn't want to have actual name here. You want to have like some user inputted name, right? So let's create a new string for that name. Initialize string, make it name equals Jabril's. Right. So how you would do this normally is you would segment this string, you would do this, and you would delete this here, and you would do plus name, and then plus the string again, right? So you have 3 different strings, but you have to break it apart to put the string variable here, and then you stitch it back together by plussing the last half of the string. I mean, listen, it works. It'll get the job done. But when you have to write a lot of strings like this, over time, it just gets really tiring and you just get frustrated. But that is where interpolated strings come into play. First, just to prove to you that this works, I'm just gonna hit the start button and then I'm gonna bring the screen over here and bada boom, it works fine. But with interpolated strings, now we no longer have to segment the strings anymore. We can bring this back together as one string and then simply come to the beginning of our string and add the $sign. This $sign denotes that the string is now interpolated. And what that allows you to do is in the middle of strings, you can add brackets. And inside those brackets, you can add variables. And so now when I print this out, check this out. This is so exciting. Now you have the same exact thing. It's just that you didn't have to break up your string. I love interpolated strings. So you can imagine if you have like a really long text or something like that, and you have a lot of variables that you need to inject into that text, you can simply just turn your string into an interpolated string and just, add the brackets and your variables all over the place. And it saves so much time and it's just beautiful. I love it. Now over in Python, it's pretty much the same thing. I'm just going to set this up. I'm going to say hello name, how are you? And the only difference in Python though is instead of a $sign, you're going to use an F for interpolated strings. And so now, we have to initialize our name variable. This is going to be Jabril's. And so now we can do the same thing, use the brackets, and bada boom. Hit play just to prove it to you. And hello, Jabril's, how are you? So beautiful. I love it. And so the final thing I want to go over is just a few handy functions that come with the string data type. And to demonstrate these handy functions, I'm going to get rid of this line. It's no longer needed. And the first one I'm going to show you is a lowercasing function. So we can just do name equals name dot to lower. And C# to lower is the method, and you just call that, add the semicolon, then we come on here and then just print out the name. And what's going to happen is it's going to take the name and then it's going to do it's going to lowercase every single character within the name. Hit start just to prove that. Bring the window over here and you'll see that it has turned this into all lowercase letters. This can be quite handy when perhaps you're creating like a database of users or something like that and you don't want duplicates. Then no matter what name they pass in to your database, you'll lowercase it every single time and then just do a match against those. That's one of the most common use cases for that function, but it's always good to know just in case you need it. Next, I want to show you the reverse of that, which is an uppercasing function. And instead of starting over completely, I'm just going to add on to our console logging. So under the first right line, I'm just going to do reset name back to equal Jabril's. And then we're going to do name equals name dot to upper is the function in C#. And then I'm just going to copy this, Control C, Control V, and now it's going to first print to the console it in all lower and then all upper. And to prove that, I'll hit the start button and bring it over, and voila. Next up, a really useful function that comes with the string data type is the split function. So I'm going to reset name. I'm going to say name equals, I'm going to do a little bit different this time though. Jabril's with a comma in the middle, because we're going to use that as our character that we're going to use to split the string apart. So with this, because we're splitting the string into two, we need to have an array instead. So I'm going to say string and then add the brackets, let the C# know that it's an array. And I'm going to call it name2 equals, and then this is where we're going to do name.split. And then we'll pass in the character that we want to use to split, and that's going to be the comma. And then we can simply just come down here and do console.writeLine and name2, and then we want to do the first element of that array, which is 0, and that is the copy and paste. And then we're going to print the second array element from that array, which is 1. And to prove that it is going to split this, I'm going to hit start here. And then I'm going to bring the window over, and you see that it split the name based on the comma, Jabril's. Beautiful. And the final handy function I want to show you is the contains function. So I'm just going to do name equals I like the spaceship. I don't know. I like the spaceship. And then we need a Boolean, because contain returns a Boolean. So Boolean, we'll just say does, and that equals name dot contains, and then we need to pass in a string here, and then we're going to say the. Does this contain the word the in it? And then simply we can just do console.writeLine does. And then just to prove that this does return a true value, if it has the word the in the string, I'm going to hit start and then bring the window over, and you can see the last right here, it returns a true. And yeah, contains is just another really powerful function that comes with the string data type. Really good use cases for that, and always good to know. And over in Python, it's just a little different than how they do it in C#. So we have our name here. We're going to do name equals equals name dot lower. And we're just gonna do print name here. I'm gonna print that out, press the play button, show you that it lowercases the name, just as we expect. And then the next one, I'm going to do name again equals Jabril's, and name equals name dot upper function, and then print name again. I'm gonna print that out, and you'll see that we have all lowercase and then all uppercase. And now this next string function is going to really demonstrate how Python has a bit of an edge over C# in this regard. So we're going to do name equals the same, jab, and then rils. And then here, all we have to do is name equals name dot split. We're just reassigning the name, and it will instantly turn this into an array. That easy, reassign it. And then all we have to do then is just do print name. And to prove that, I'm gonna hit the play button, and there you have it, jab rils. Yeah, personally, this is one of my favorite reasons for using Python, is because of the ease of doing stuff like this versus over in C#, how we had to have our string name and we had to initialize a new string array to hold the new string array we're about to make and then print them out one at a time. This is just like 3 lines of code, easy, simple. One of the advantages that I love using Python. And the final one is the contains function. So we're just gonna do name equals I like the space ship, and then come on down here and we'll do does, initialize a boolean called does, and then we're going to do name dot contains. I'll explain why this looks weird in a second. And then we can print does. All right, just to prove that works, gonna press play, and it does not work. And that is because, of course, I forgot to save it. So hit save and then hit play, come on down, and there you have it, true value. I really just want to pause for a second here and emphasize that Python really doesn't care if you use double quotes or single quotes. As you see, we're using double quotes here for the name and single quotes for the string that it contains, and it still returns true. It just interprets. Now, the reason why this part looks so ugly is because this is what's called a wrapper method. Or a method wrapper rather, and it's not important for you to understand what that term is yet in your early days of programming, but essentially what this is, Python doesn't want you to use this way. How they prefer you to use it is if you were to go if and then the in name. So if the string the is in name, then we'll do print does. Python really prides itself on, being a language that's kind of close to how we actually, use language as humans. So this is how they prefer for you to use this method rather. And just to prove that, we're gonna hit play. We'll make sure I saved it. Hit play, and we should see 2 trues, which we do. And that does it, guys. That's pretty much everything that you need to get started with programming in terms of strings. Char data types are pretty easy to grasp. Char is short for character. And if you know how to read and write in any language, then you know what a character is. First letter in your name, character. The letter you got in math class, character. That hashtag symbol that you overuse on social media, character. Any letter from any language, any single digit number, any sign or symbol, even some glyphs like the yin and yang sign are a single character. But that's a bit beyond the scope for this course. Just keep this in the back of your mind for when you want to learn more about them. But for now, just know that characters are very important in the world of programming. They share a lot of overlap with the string data type because a string of characters is what makes up a string. In fact, way back in the early days of programming, like with the language C, strings didn't even exist as a data type. You instead had to create an array of characters. But strings like desktop, downloads, C:\program files that all your applications are installed in are all a series of characters that computers use on a daily basis to make your computer experience as smooth as possible. Characters play an essential role for computers being able to communicate and relay information to us. And that's pretty much all there is to it. Now from here, there's not really much to go over, but let's have a quick look at how we go about using characters in 2 different languages, because I think it can be really helpful to see how they compare and contrast, and plus, you'll pretty much learn 2 languages at once. So on the left, it's the language C# using the IDE Visual Studio, which should interest you if you want to do Windows development or want to make games using a popular engine called Unity. And on the right is the language Python 3 using the IDE Visual Studio Code, which should interest you if you want to get into more general programming or data science. Alright, so here I have 2 brand new console projects, and if you don't know how to make a new console project in either C# or Python or both, be sure to check out the video in the description. It's called How to Install an IDE, and at the end of that video I'll show you how to do that. So first things first, let's look at some basic char syntax. So over here on the left in C#, I'm just going to remove that comes standard with your blank console project, and then I'm going to write char, which is casting our data type, and then we'll call our variable a, and I'm going to assign a z character to it. Now this is how you write a character. A character in C# must always be in the middle of 2 single quotes. And it's really as simple as that. We can put any character we want here. We can put A, we can put J, we can put 8, we can put $. Any character you want can go in between these 2 single quotes. And there you have a char. Now over in Python, assigning chars is just a little bit different. So we can do just as we do in C#, we can do A equals single quote Z. However, we can also do A equals double quote Z. And Python will accept either one, and it will figure out that these are both a char. But you'll see if we go back into C# and then change these from a single quote to a double quote Z, you'll see that we'll get a type error. In C# it specifically uses double quotes for strings and single quotes for chars. But again, in Python, it's pretty smart with figuring out, if it's a char or a string. One of the benefits to an interpreted language. And just to prove to you that this is the case, I'm going to actually change this to variable b, and then we're going to do print a, and then we're going to do print B, and we're going to hit the play button up here in the corner, and you'll see down here in the output it prints both of them ZZ, no problem. I'm going to change this back to single quotes real quick. Alright. Okay, so now with the basic char syntax out of the way, let's talk about escape characters. Now, what are escape characters? There will undoubtedly come a time where maybe you're writing out some story or creating like a list of names or something like that, and you will undoubtedly come across the question, how do I press enter or hit tab or insert quotes? How do I do these things? Well, that is where escape characters come into play. Alright, so now let's initialize an escape character. I'm just going to cast a new variable as a char, and then inside my character, I'm going to hit backslash. Now, technically, backslash is the escape character. It likes to escape the syntax of characters, but I like to call the whole character as an escape character. It's up for debate, but I'm going to hit backslash n, which is one of the most common escape characters called new line. Now, I really want you to understand how important escape characters are. If I were to, for example, replace the backslash with forward slash, for example, you'll see that we'll get an error down here for too many characters and character literal. Everything within these single quotes is what's called the character literal, and you can only put 1 character per character literal. These count as 2, but when you put the backslash, that counts as 1 character literal, which again, this is a new line escape character. And just to prove to you that it actually does what I claim that it does, we're going to do console.writeLine. This is just going to print to the terminal for us. I'm going to print A, which is a variable that has Z in there. And then we're going to do a B, and then I'm just copy and paste, Control C, Control V, and then we're going to do another A. So what we should see is going to print out Z, and then new line, and then another Z. I'm just going to run that, and it's off screen. Oops, I forgot. I have to also do console.read key. Otherwise, the console will not stay open. So hit start, it's off screen here. I'm going to bring it on the screen and you'll see that we have exactly what we should expect. Now, I know there's some of you out there probably going, wait a second, Jabril, that is not what I expect. There are 2 spaces in between the Z's. And let's just pause here for a second and really examine the logic of our program. So the reason that we're getting 2 lines in between A, B, and A when you probably expect no lines in between them is because the function writeLine itself, it does a new line for us. So it prints out Z, A equals Z. It'll print out Z and then it'll go to a new line, and then it'll print out a new line and then go to a new line and then print out Z, then go to a new line. And I'm going to just run that one more time, just confirm that's what happens. Prints out A, goes to a new line, prints out a new line, goes to a new line, then prints out Z, then goes to a new line where it ends there. So it's doing exactly as we want it to do. It just looks a little weird in this context because the writeLine function adds a new line without really telling us it. Yeah. All right, so now with that out the way, let's check out our escape characters in Python over here on the left. I'm just going to change our B variable to be single quotes. I'm just going to use single quotes because it's easier convention between the two. And we're going to do a new line. And I have that backwards, supposed to do backslash. And you can see in Visual Studio Code, it'll actually slightly tint the escape characters yellow for you to help you give a little more assistance, which is nice. Visual Studio Regular doesn't really do that. Anyhow, new line, and then we're going to print out A, and then we're going to print out B, and then I'm just going to copy and paste one more A. And then let's run this by hitting the play button, and you'll see that we have the same exact result that we have in C#, and you already know why there are 2 lines there. Moving right along, let's take a look at concatenating characters. Concatenating, it just simply means taking a few different things and putting them together. So if you have 3 different characters, for example, you can concatenate them and they become one word or one phrase, what have you. That's all to concatenate means. So to concatenate characters, you would think it would be as easy as, you know, a new character, C equals A plus A. But it's not that simple. In C#, when you add 2 characters together, the character data type takes the addition operator and turns the characters into ints. In fact, every single character under the hood actually has an integer value assigned to it. If we take a look at this chart here, this is the ASCII chart, part of Unicode, you can see that every single character has some sort of decimal value assigned to it. So we could take the character 2, for example, and do 2 plus 2, and that will get us 100, which is a lowercase d character. But just know there aren't too many use cases for operations like that. Just know that this is how it works under the hood. It's interesting stuff to know, but let's move on. So what you want to do is you actually want to turn your characters into a string, just like that. And then you'll get an error because, again, when you use the addition operator on characters, they get turned into ints, and you're trying to assign an integer to a string. So a way to override that is simply just write 2 double quotes and then just plus to it. It's like a shortcut to quickly convert whatever the assignment is to a string. The assignment, again, is everything that's on the right side of the variable. And so now we can just add all of our characters to the string C. And so I'm just going to do A plus B plus A, which is Z plus new line plus Z. And then I can delete 2 of these right lines, and then I'm going to add C instead of A. And then I'm going to hit play, and I'm going to bring this over, and you can see here that it's a bit different now. Now, why is that? Well, let's take a look. Again, writeLine, every time that you call this function, it will return to a new line. However, we used a string and only one writeLine, so there are no new breaks other than the one that we coded in. So it literally does print Z, go to a new line, and then print another Z, as you see here. Print Z, go to a new line, then print Z. So that's what's going on there. Everything with programming, it's always really basic logic that you have to follow. And yeah. Now in Python, because Python is an interpreted language, it makes doing stuff like this really easy. All we have to do really is just do C equals, then we can do A plus B plus A. Simple as that. Come down to our prints. We don't need two of them, so I'll delete two of them and then just replace A with C, and then save that, hit the play button in the corner, and you can see that we have the same exact result. It prints out an A, goes to a new line, prints out a Z, goes to a new line, and then prints to another Z, as you see here. Simple, easy. God bless Python. So that's pretty much all that's to concatenating characters. Let's now take a look finally at the remainder of the most important escape characters. So you already know \n, or the new line escape character. There's another pretty important one that you should know as well, and that is \r. This is the return character. So what the return character does, it returns back to the beginning of the line. Now, back in the old days, this was really important to use because you would go to a new line, but it wouldn't return back to the beginning. Just wherever you left off in the previous sentence, it would just go to a new line at that same exact spot. So you had to call the return escape characters to make it go back to the beginning of the line. So what happens if we were to run this in the console? Let's hit start, the play button. I'm going to bring it over, and you'll see that we just have one character, and that's Z. Even though we have Z return Z, what's happening is that it's printing out Z, but then it's going back to the beginning of the line and then printing Z again. And just to prove this, we can change this to Y. And then just for extra proof, we can add a plus U and hit start play button, and you'll see what happens is it prints out Z, but then the return character returns back to the beginning of the line, and then it prints out a Y, and then it prints out a U, essentially overriding our first character, which is Z. Now, in the new modern age, you're not really going to use the return character too much. However, I bring it up because it is good to know. There might be some scenarios in which you might be using an older terminal or an older engine or something like that, and you're losing your mind that you're using the new line escape character, but it's not returning to the beginning of the sentence. Here, this is the return character. Use that, all your problems will disappear. Furthermore, in most new modern programs and terminals in X, Y, and Z, the new line is actually looks like this. It always looks like new line and then return. And we can demonstrate that. Interestingly enough, if we come over to Python and replace the new line escape character with a return escape character, hit save and then play, you'll see that what we get is not what we expect. It actually is a new line instead of a return. And the reason for this is because what we're using to interpret the code is something called Code Runner. And the way that Code Runner interprets a return escape character is likely like this. I can't verify it, but this is likely how it interprets just a regular return character. Thus why we have a new line and a return. And furthermore, if you really want to see the difference between Code Runner and the terminal PowerShell that ships with Microsoft Windows, you can hit right click on the name of the Python script, reveal in Explorer, and then just double click on this to run the Python script. Oh wait, I'm sorry, we have to add input here. Input will keep the terminal open. Double click on the Python script, and there you have it. We have exactly what we expect. That is just the difference between two different terminals interpreting code. Okay, I hope that wasn't too confusing. Again, you won't really have to worry about using characters in this manner. Oftentimes, most people don't even interface with characters this low level, but it is good stuff to know when you're dealing with strings all the time. And yeah, let's move along. The next escape character is \T, which is a tab character. I'm just going to turn this back into our simple string, and then I'm going to hit the start button, bring the console over, and you can see that it's just Z tab Z. Simple as that. Python, it's the same. Just do a \T Then we can hit the play button. You can see that Z tab Z. Easy. So the next escape characters we're going to look at are the quote escape characters. So at some point you might want to add the character single quote or something like that. And you go to do that. You're like, okay, cool. Single quote. Wait a second. How do I do that? Well, of course, simply put, you just add the escape character backslash and then single quote. So this right here, these two pieces, the backslash and the single quote, is the single quote escape character. And of course, you can do the same thing with that for string. So let's say you want to write out some code or something, you can do a backslash and then a double quote. And that is the double quote escape character. So now if we just run this program, hit the start button, you can see that we get some really weird string with the double quote Z, single quote Z. This is just a demonstration to show you how you can use quotes if you really need to. And now in Python, it's actually a little bit different. So we can still do the same, use the backslash, whoa, I meant to replace that, backslash and then single quote to get our escape character. Single quote, for example, you can hit play. Oh, it's saying it's already running. Oh, of course. I have to stop code run. Right click on the output and then do stop code run if you have input. Just a quick caveat because you won't be able to hit that play button anymore. But I'm going to hit play. And you'll see that we have our single quote escape character. I can replace with double quote. Same deal, right? Hit the play, and you see that. Oh wait, I have to save it. Sorry, and then hit play, and you'll see they have a double quote. No big deal, right? Now, how Python is a little more special, a little different, is that we can use either single quotes or double quotes for a character literal. So we can, if we want to use a double quote, we just use single quotes on the outside, and then I'm going to save that and hit play, and it's the same exact thing. But if I want to use a single quote, I can change the outside quotes to be double quotes like so, and just put a single quote in the middle, and then save that, hit play, and you see that we have a single quote in the middle of two Z's. So that's another benefit to an interpreted language. It might save you a bit of time there, but it's just, yeah, it is what it is. And the last important escape character is actually the backslash itself. At this point, you already know where I'm going with this, but if you want to write a backslash escape character, you just have to do backslash to escape out and then another backslash. So 2 backslashes will get you 1. And just to prove that, I'm going to remove this right there, and then I'm going to hit the start button, bring this over, and voila, Z backslash Z. And over in Python, it's the same exact thing. You just have to do backslash to escape out and then another backslash. And I'm just gonna save it, hit play, come on down, and there you go, Z backslash Z. And there you have it, guys. That's pretty much everything you need to know to get started with programming in terms of characters. Let's talk about floats. Floats stand for floating point values, or floating point numbers. Both are pretty much the same thing, in which you can think as numbers or values that float somewhere in between integers. So if both 1 and 2 are integers, with 2 coming right after 1, then a float makes up all the numbers in between 1 and 2. 1.1, 1.2, 1.3, 1.4, 1.5, all the way to 1.9. But make no mistake about it, floats aren't limited to just one decimal place. The value pi, for instance, is a float. It's most commonly represented as 3.14, but we have no idea how many actual decimal points pi has. As it stands, researchers have calculated the 2 quadrillionth digit for pi and are still researching how to calculate even more digits. So in short, the floating point values in between 2 integers are infinite. And that is pretty much the basic to floats. They can honestly take a little work to understand them in their entirety, but for now, all you need to know is that they are values in between integers. So now, let's take a look at a few examples on how to use floats with code. And we're going to do this by using 2 different languages, because I think it can be really helpful to see how they compare and contrast. And plus, you'll pretty much learn 2 languages at once. So on the left is the language C# using the IDE Visual Studio, which should interest you if you want to do Windows development or if you want to make games using a popular game engine called Unity. And on the right is the language Python 3 using the IDE Visual Studio Code, which should interest you if you want to get into more general programming or data science. Alright, so here I have two brand new console projects, and if you don't know how to make a new console project in either C# or Python or both, be sure to check out the video in the description. It's called How to Install an IDE, and at the end of that video I'll show you how to do that. Alright, so the first thing I want to get into floats is the different operators. If you're familiar at all with the operators that integers use, then you'll be quite familiar with the operators that floats use as well. Why? Because they are the same exact operators. So jumping right into it in C# here on the left, I'm just going to get rid of these two lines because I don't need them anymore. They come standard with every single new console project. And I'm just going to initialize a float. So I'm going to type out float, and then I'm going to call it A just for an example, and I'm going to assign 0 to it. Actually, that's no fun because 0 is an integer. So let's assign 7.77. That sounds fun. Now actually, before we get into talking about operators, let's touch a bit on the syntax. Between Python and C#, there's not really much to the differences between the syntax of floats. However, in C#, you do have to clarify that your numeric value is a float by adding an F at the end of the numeric value. This is just further instructions to tell the compiler on how they should go about handling this numeric value. Simply meaning when your code is turned into instructions for a computer to do, when it gets to this line right here, it reads the float and it knows without any confusion that this is a floating point value. However, there is a caveat. Even though this variable A is a float variable, you don't always have to add the float to the end of your values. For example, if you instead just say float A is an integer 7, floats automatically can convert themselves from integers to floats. Therefore, you don't have to add the F. Now, while in C# you have to add the F at the end of floating point values, in Python you don't have to do that. All you have to do is just type out whatever value that you want to do, 7.77, and Python will take care of the rest for you. And Python is able to do this because it's a type of language called an interpreted language, where all you have to do is assign a value to a variable and it will interpret what data type that variable should have. Which in a lot of cases is pretty nice because you don't have to worry about the differences between floating point values or integers. You can just do sums and multiplication, division, and not have to worry about any of that stuff. But now let's get into some operators, starting with the increment operator. So an increment operator does exactly what it describes. It increments. And the syntax for that goes like this. A++. That's it. If we were to come down here and do a console.writeLine, that just will print to the console for us. And then we also need a console.read key for C# so that the console doesn't close on us. And I'm going to hit the start button and bring the console window over. You can see that it just increments it by 1. Plus 1 to 7.77 gives us 8.77. And that is the increment operator. Now, in my experiences, it's not like a terribly good handy tool, but it can save sometimes. Oftentimes, if you just want to add 1 to something instead of having to do like a full out other operator, you can just do, the variable plus and you're done. And to do the increment operator in Python, you actually can't do an increment operator in Python. If we were to type out A++, you can see that our IDE shows that it's red to let us know that this is not a thing in Python. Every language is different and Python just doesn't care about the increment operator, I guess. So now imagine that you want to add more than 1 to your float. How would you go about doing that? Well, that is where our next operator, the addition operator, comes into play. The syntax for the addition operator goes like so. So you want to do A, or your variable, your float, plus equals, and then whatever value. So we can do plus equals 1 to do another way to do an increment operator, or we can pass in a float. We can do, for example, 3.33f. And again, I added an f to the end of this value because it is a floating point value. And if we were to run this, hit the start button, bring the window over, you can see that we got 11.1. Now, just a minor note, just to make sure we're covering all bases, you can see that it does not print out 11.1f. And the reason for that is because the f is something that only the computer needs. Once the computer sees the code, reads the f, and sees that it's a floating point value, there's no point to return that back to us because we're humans and we're smart and we know the difference between a float and an int just by looking at it. Moving along. To use the addition operator in Python, it's absolutely no different syntax-wise. You do your variable, in our case a, plus equals 3.33. And again, we don't need to add an f because it's Python and Python doesn't care about f's. If I were to come down here and write print a, and then save it and hit the play button, you can see down here that we will get 11.1. And as far as adding is concerned, the final way that you can add a value to your float is by doing something that I like to call a modified assignment. Now, this isn't a technical term. I'm not sure if it has one or not, but I like to distinguish this from regular assignments. So what we're going to do is just get rid of all of this just to clear up confusion. And then we can do a equals a plus 3.33f. And there you have a modified assignment. Now, whoa, what's going on here? It looks a little bit confusing. Well, don't worry. Let me walk you through it. First thing you need to know is that this is the assignment operator, and everything that is on the right side of an assignment operator is calculated first. So whatever the state of A is, which in this case is 7.77, is going to be added to 3.33. And once that result is calculated, then it's going to throw that result to the left side of the assignment, which is, again, is A. So in a sense, we're assigning A to equal what it currently equals plus some extra value. We're just updating it, really. Just a few different ways to do the same thing, but you as the developer have the choice to go with whatever best fits your programming styles. And just to prove to you that this is the exact same result, I'm gonna hit the start button and bring the window over. You can see that again, we have 11.1. And over in Python, to do a modified assignment is the same exact syntax. So I'm going to remove this line just to clear all confusion, start over, and we can do a equals itself plus 3.33. And just to prove to you it's the same exact result, I'm gonna hit the play button and you can see, boom, another 11.1. Next up, we have a few operators for subtracting, and the first one is the decrement operator. Well, you already know what the increment operator does, so guessing what the decrement operator does should be a no-brainer. Yes, you guessed it, it simply just minuses 1 from your float. And just like the increment operator is plus plus, well, the decrement operator is minus minus. That's all there's to it. And to prove to you that it does what I say it does, I'm going to hit the start button, bring the window over, and you can see we have 6.77 because 7.77 minus 1 is, of course, 6.77. And again, from my experiences, not the most helpful operator out there. It can help you save some time writing code here and there, but it is what it is. And also, again, in Python, just as they don't have the increment operator, well, they also don't have the decrement operator. I can type out a minus minus, and you can see it turns red, letting us know that this is not a thing in this language. And so, if you want to subtract more than 1 from your float, you can use what's called the subtraction operator. And the syntax for that is probably just as you expect. Minus equals, and then your float value, or your integer value, whatever numeric value. And just to prove it to you, I'm gonna hit the start button and bring the window over. And as you can see, 7.77 minus 3.33 equals 4.44. And over in Python, the subtraction operator is the same exact syntax. I'm going to get rid of this, start over. A minus equals, and then your value. And just to prove that to you, I'm going to hit the play button, and you can see that we have 4.4399999995. Now, some of you are probably going, what's up with this discrepancy? C# said 4.44, but Python says 4.43999, blah, 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 blah. Well, I'm just going to give it to you straight. Floating point values is something made by the devil. It's important to remember that floating points are the values in between integers, and that space in between any two integers is infinite. And anything dealing with infinity, But long story short, if you're just starting out, you don't have to concern yourself with things like this at the moment. At some point in time, perhaps you might dig into some project that requires like really precise floating point precision. and at that point you can pull your hair out. But for now, just know the reason why you're seeing this is because in C#, floats are rounded to the nearest digit. There are more accurate data types, but that's beyond the scope for this course. And for almost all your applications, 2 to 3 point floating precision is oftentimes good enough. You don't need to worry yourself with this kind of accuracy. It's part of the reason why we have calculated about, I think, the quadrillionth digit of pi, but we often just round it off to 3.14 because oftentimes that's a good enough precision estimate. Moving on, the final way that we can subtract is, of course, by using a modified assignment. And to do a modified assignment for subtracting, all we do is get rid of this and we do a equals itself minus 3.33f. And just to prove to you that works just as I say it does, I'm gonna hit the play button, bring it over, and you can see that we have 4.44. And over in Python, the syntax is no different than C#. We can do a equals itself minus 3.33. I'm gonna save, hit the play button, and you can see that we got 4.43999. Next up, the multiplication operator. Whenever you want to do multiplication to your floats, you simply just have to use the multiplication operator. And the syntax for that goes like this. A times equals 2, for example. And when you run this, it's simply just going to take your float A and times it by 2. And to prove that to you, I'm at the start button and bring the window over. You can see that 7.77 times 2 equals 15.54. And of course, what you times your float by doesn't have to be an integer. It can be a floating point, but of course, it just has to be some numeric value. And over in Python, the syntax is the same exact as it is in C#. A times equals 2. Prove that to you, hit the play button, and you can see that we have 15.54. And of course, another way we can do multiplication is if we do a modified assignment. And the syntax for that, of course, you already know it, is A equals A times 2. Prove that to you, I'll hit the start button and bring the window over, and again, we have 15.54. And in Python, the syntax is no different. We can do A equals A times 2, and then I'm gonna press play and show it to you that again we have 15.54. Now, one thing that you didn't see me do is like something like A times. And the reason for that is, unlike subtraction or addition, there is no sort of incrementing multiplication. What does that even mean, really? And so moving on, the final operator is the division operator, which the syntax for that goes as follows. A divided by equals 2. Now let's make it interesting. Let's say 2.15. And of course, what this is going to do is going to take our A float and it's going to divide it by 2.15. And to prove that to you, I'm going to hit the start button and bring the window over. And you can see that we have 3.613953. That's going to be fun to say over and over. And over in Python, the division operator is the same exact syntax. So we can do A divided by equals 2.15. And to prove that to you, I'm going to hit the play button, and you can see that Python is a lot worse. We have 3.613953, and it goes on and on. I know that I'm kind of demonizing the long decimal points with Python, but it's actually a good thing that they give you this precision right out the box. And the final way we can divide is by using a modified assignment, which the syntax for that looks like this. I'm just going to start over to make it a bit less confusing. A equals A divided by 2.15f. And just to prove that to you, I'm gonna hit the start button and bring the window over. You can see again, we have 3.613953. And yeah, there you have it. Floats are pretty useful in the world of programming. They're used for a lot of different applications. And don't let me scare you with the whole floating point precision talk. It's very, very rare that you'll have to be in this world of floating points. Usually you won't go no further than like 2 or 3 point precision, which at that precision, everything's really simple to understand. But that's pretty much everything you need to know to get started with programming in regards to floats. It's time to talk about arrays. Now, arrays are most often used with loops, but they can be used in almost any context. So, what is an array? Well, you can think of an array as essentially a container that holds a fixed number of variables that all have the same data type. So the fact that they're just containers that hold variables You can use these variables independently in any context. Say you want to update an array full of names with a couple of lines of code, or maybe easily save an array of 100 emails to a file, without having to copy and paste and change a variable here and there. Well, arrays make doing things like this really easy to do. But instead of going on and on with examples about how arrays are the coolest thing since sliced bread, let's just jump right into looking at a few examples and use cases to learn how do we go about using arrays with code. And we're going to do this using two different languages because I think it can be really helpful for you to see how they compare and contrast, and plus you'll pretty much learn two languages at once. So on the left is the language C# using the IDE Visual Studio, which should interest you if you want to get into Windows development or make games using a popular game engine called Unity. And on the right is the language Python 3 using the IDE Visual Studio Code, which should interest you if you want to get into more general programming or data science. Alright, so here I have two brand new console projects, and if you don't know how to make a new console project in either C# or Python or both, be sure to check out the video in the description. It's called How to Install an IDE, and at the end of that video I'll show you how to do that. Alright, so let's get a bit into arrays. So arrays are simply just a data structure, meaning it's a certain way in which you can structure your different data types. So I won't get into too much in how to use arrays, otherwise this video will turn into just like a long list of examples, but let's jump into this. So the first thing I want to touch on is the different syntax for arrays in both C# and Python. But before we do that, I want you to imagine that you're making some sort of 4-player game, let's say, and every single player starts with the same amount of HP. So let's create those variables. First, over here on the left in C#, I'm going to get rid of these two lines because I don't need them. They come standard with every console project. And I'm going to initialize an integer. I'm going to call it HP1. I'm going to assign that to be 100. And then I'm going to do it again. Assign another HP2 equals 100. And then int HP3 equals 100. And then finally int HP4 equals 100. Great, so we have 4 different integers for 4 different players. But with arrays, there's no need for 4 different variables. We can simply come up here and initialize a new integer array. And the syntax for that goes as follows. First, we want to type out the data type that we want to put into an array, which of course in our case is an integer. And if you want to denote that this is an array, you simply just add a start bracket and an end bracket. This right here is how you denote an integer array data structure. And so after that, we just type out our variable name, which I'm going to call it HP, and then we have to assign to it a new integer array. And then within the brackets here, you have to specify the size of your array, which we have 4 players, so the size is 4. Add a semicolon and you are done. So now that we have our integer array with a size of 4, we can now assign values to what's called the elements of that array. And to do that, I'm just going to come down here and I'm going to say HP, and then I have to bring back the start and end bracket and then type in the element number. Again, it's the size of 4, so we're going to start with 0. Alright, so you probably just got a little confused on why I started on 0 instead of 1. Well, in most programming languages, arrays always start on 0. Why, you ask? Well, 0 is a number 2, and in computing, 0 is actually the first number. Not the biggest deal, but a really simple fact that is important to remember, because if you start on 1, you might get a lot of errors and might want to pull your hair out. So just remember, with arrays, 0 is always first. Anywho, we have the HP integer array at element 0, and what we want to do is assign 100 to it. And now we just want to do this for all 4 elements. I'm going to do HP of element 1, assign another 100 to it, do HP of element 2, if I can type, and then assign 100 to it, and then finally HP of element 3 and assign 100 to it. Again, quick note, you can see that we ended on the element 3, although we initialized an integer array with the size of 4. But if you were to count them, you can see that we have 4 elements here, 0, 1, 2, and 3. And of course, the reason for this offset is because in computing, we always start on 0. It can trip you up a lot at the beginning, but it's something that you'll get used to eventually. Now, I know if this is your first time learning about arrays, it can be quite difficult to get a conceptual grasp on what's going on here. And so I'm going to walk you through a quick visual. So what we have here is an array with the length of 9. 0, 1, 2, 3, 4, 5, 6, 7, and 8. This bottom row right here is the index, or the element. They're both interchangeable, but for this course, I'm going to be calling it the element. And this top row is the value at that element. And so, if this were our HP integer array, it would end right here, right at the third element. And after we initialized the integer array, it was filled with all zeros in the value spots. And so, what we did in the code is we simply went through and assigned 100 to every single element in that array. And that conceptually is what's going on with arrays. And that's not just for integers, it's for every single type of array. If you have a string array, a float array, a character array, what have you. Now, with that out the way, we no longer need these variables. We can delete those. And then to prove to you that these work as I say they do, I'm going to write a console.writeLine so that we can print this to the console, and I'll do HP 0 and then semicolon. I'm just going to hit Control C, Control V, copy paste a few times, and simply just change element 0 to 1, 2, and 3. We're also going to need a console.read key. This is so that the terminal doesn't close when we run it. And now I'm just going to come up here to the start, hit the start button, and then bring the console window over to show you that we have 4 players with 100 HP initialized. Now, last thing I want to mention on this is that if you try to assign a value to an element that is outside of the range for that array, then you will get an error. And to demonstrate that, if I come here and do HP of element 4 and assign 100 to it, hit the save button, then play, and you can see that it gives us an exception saying pretty much that we don't have an array of this size, therefore you can't assign to the 4th element. So just be mindful of the size of your arrays. Now over in Python, the syntax for arrays are a bit different. And Python actually doesn't even use arrays. They actually use a type of data structure called a list. And you can initialize a list in Python in 2 different ways. But the syntax for the first one goes as follows. First, we're going to write out the name of our variable, which of course is HP. And then we're going to do equal, and then start bracket, and then you just type out whatever values you want in here. So again, we have a 4-player game with 4 different players with 100 HP each. So I'm simply just going to write 100 4 times with a comma separating each of them. And there you have it. It's done. And then to prove it to you, I'm just going to write print and then pass in the whole array HP, hit the play button, and you can see that it prints out an array with 4 elements. As you can already see, Python has a huge leg up when it comes to doing this type of stuff. In Python, we really only had to do 2 lines of code. In C# we had to do, 8, 9, 10, about 9 different lines of code. Big difference. And the reason for this, you might ask, is just the design philosophies with the languages. Python is more designed to be really easy to use and do a lot of data stuff, and C# was kind of piggybacked off of the C language, so they had to carry over a lot of stuff that C was already doing. But yeah, you get to pick and choose. There are pros and cons with both of them. So that was the first way that you can initialize a list in Python, and here's the second way. I'm just going to come down here and do HP equals empty array. And then it's as easy as hp.append. And then you're going to do parentheses because it's a function. And then you want to append whatever you want. So I'll append 100 for the first player. And then I'll append again another 100 for the second player. hp.append for the third player. And at last, hp.append for the last player. And just to prove to you that does exactly what I say it does, I'm going to do print. Again, HP. Come up here to the top, hit the play button, and you can see that we print out 100, 100, 100, 100 2 times. Now, this function is one of the benefits to using lists over array, is that you can initialize an empty list and just add to that list. And C# has one too, but it's a bit beyond the scope for this video. Okay, so let's now talk about the real thing that makes arrays so powerful, and that's array iteration. Alright, so this is cool and all. We have all of our player HP in one variable. But what if instead of 4 players with HP, you had 100 players with HP? This would get old quick having to write this out 100 times. Well, that is where for loops come into play. Now, arrays and for loops are like burgers and fries. They're just a perfect combo. So now let's bring in a for loop so that we can easily assign a value to the elements in our array. So I'm just going to come up here above our variables here, and I'm just going to write out the for loop syntax. So for, and then int I equals 0, and then semicolon, and then if I is less than, we have 4 elements, so 4, and then we're going to do I++ if that is true. And then we need to add our code block here, and then we simply just need to write our variable into here. So I'm not going to go too much into the for loop on how it works because I have a full episode about that, so check that out if you're confused. But essentially, on a very layman's level, the for loop, it simply just assigns 0 to our integer here, and then if it's less than 4, then we're just going to add to it every single update. And we can then use the I as a location within the for loop. And so with that, if this for loop is less than 4, then it will increment, meaning it's going to stop at 3. Which is exactly what we need because our element also stops at 3. And so what that means is that now we can change this 0 element to I element. And we no longer need these because they will be set with the for loop. In addition to that, because we're also using the array element for printing, we could even come down here and do console.writeLine and then HP of I elements. Meaning we no longer need these lines either. And so now, just to prove to you this works, I'm gonna hit the start button, and then I'm gonna bring the window over. You can see that we have 4 100s. So now back to the scenario I set up. Say instead of 4 players, you wanted 100. Well, we simply will come to our array size here, and we'll change the array size to 100. And we also need to change the iteration for our for loop. We want to stop at 100. And to prove that to you, I can just hit the play button and then bring the window over here, and there is 100 100s. It's a bit hard to tell, but there's 100 100s here. And over in Python, again, the syntax for this is a bit different. So I'm just going to get rid of these lines because let's just start over. But again, we do have 2 ways we can go about doing this. And the first way is really simple. All you got to do is do HP and then assign an array of 100, but times that by 100. And to prove that to you, I'm going to do print HP and then hit the play button, and you can see that we have 100 100s in an array. Simple, easy, and to the point. Gotta love Python. And for the second way, it's a bit more involved. I'm gonna come down here and initialize an empty array, and then we're gonna do a for loop. The syntax is a bit different in Python. For I in range of 100, and then and then I'm going to come down here, and because it's an empty, well, I said empty array, but it's actually empty list, we're not going to get like the element of anything. We're simply just going to do hp.append and 100. So then down here, all you gotta do is print HP, and we should get 2 arrays of 100 100s, which probably is going to be a bit confusing, but let's do it anyway. Hit play. And yeah, there is the second one and there's the first one. Completely identical. 2 ways to go about doing it. You as the developer, you have the choice on which one you want to use. And so yeah, that's pretty much the basics, all you need to know to go about using this data structure. Anything from this point on would just be me listing out a million different examples on, you know, different use cases, but pretty much from this point on, it's up to you as a developer to get creative and apply this data structure in different ways. And hopefully you were starting to think of some different creative ways on how you might be able to use arrays or arrays and for loops together. But that is everything that you need to know to get started with programming in regards to arrays. Okay, let's talk about the big bad variables. Without even talking about programming, what does variable mean? Variable, defined by dictionary.com, is something that has the ability to vary or change. And believe it or not, it means the same exact thing in programming as well. A variable is something used to store data. You can think of it as a container, but what you put in this container can be changed and updated, giving it the name variable. Now, there is one very important thing that requires understanding when talking about variables, and that is data types. If you can grasp this thing about variables, I think you'll save yourself a log of annoying errors, especially in the beginning. When you create a variable, all languages need to know the data type of your variable. And to again think about a variable as a container, imagine that we have two data types that we want to store into a container. Let's just say one data type is reptiles and the other is fish. Well, you can't store these two data types in the same container. Fish need to be surrounded by water in order to breathe, and reptiles need land and often hot, dry climate in order to stay comfortable and alive. So, what happens if you drop a reptile into a container meant for fish? That's right, you'll get a type error. Just as if you create a variable meant for booleans and try and assign a string to it. So, how do we actually go about using variables with the different data types and etc.? Well, it's quite simple actually. Let's take a look at some examples using two different languages, because I think it can be really helpful for you to see how they compare and contrast. And plus, you'll pretty much learn two languages at once. So on the left is the language C# using IDE Visual Studio, which should interest you if you want to do Windows development or want to make games using a popular game engine called Unity. And on the right is the language Python 3 using the IDE Visual Studio Code, which should interest you if you want to get into more general programming or data science. Alright, so here I have two brand new console projects, and if you don't know how to make a new console project in either C# or Python or both, be sure to check out the video in the description. It's called How to Install an IDE, and at the end of that video I'll show you how to do that. Alright, let's start off by looking at initializing some variables and the syntax of that between C# and Python. So over here on the left in C#, I'm going to start by getting rid of these two lines because I don't need them. They come standard with any new console project. And now let's take a look at the 5 main data types. First up, we have booleans, and you can initialize a boolean like so. Just type out the word bool and then whatever name for your variable. In this case, we'll just do A. And now let's initialize our next data type, which is a char. So you do that by typing out the type of data, which again is char, and then name your variable. Let's just keep in alphabetical order going here, and I'll just name it B. And now the char has been initialized. Let's initialize our next data type, which is a string, and we do that by typing out the type of data, which is a string, and then keeping the alphabetical order, we'll just name it a C. I think you can get the pattern at this point. We're going to initialize our next data type, which is an int. Just type of the type of data and then name the variable. We'll call it a D, keep the order convention going. And our last data type is a float, which we'll call an E. And there you have it. Initializing your variables in C# is pretty straightforward. You just type out whatever type of data you want to initialize and then name that variable. And that's for all data types. However, this isn't the only way that you can initialize variables. You could also assign something to those variables when you initialize them. And to assign something to variables, you have to use what's called the assignment operator, which don't let that scare you because it's as simply as just typing equals. Equals here, this sign is what's called the assignment operator. It allows you to assign something to a variable. And for this boolean, let's just assign it to be true. So let's go through and assign something to all of our variables. So for our char variable, let's assign the letter J to it. And then for our string, let's assign the string candy to it. Our integer, let's assign the number 13. And then for our float, let's assign 7.77f. That's a good number. And there you have it. That is another way that you can initialize a variable. But heads up, it's always best practice to initialize your variables with an assignment, like true, J for example. These are assignments. And the reason for that is because, like the previous example, if you initialize them without any assignments, sometimes they can return null. And if you're using that variable, you might come up with some weird edge cases and you'll get errors. So it's always best practice to just assign a value to your variables whenever you initialize them. Now, to initialize variables in Python, it's a lot simpler with a slight caveat. So Python does away with the idea of having to cast your variables. So like over here in C#, we have to cast that our A variable is a bool data type, cast that our B variable is a char data type. Typing the type of data next to it is what's called data casting. And in Python, you don't have to do that. All we have to do instead is simply type out the name of our variable and assign something to it. So if we want to make a boolean, we just assign a true value to it. The Python language is a type of language classified as an interpreted language. And what that means is Python interprets the data type of your variables depending on what you assign to it. So at the fact that we assigned a true value to the A variable, when you go to run your Python script, Python will know that the A variable has a Boolean data type because we assigned a Boolean value to it. And this goes for all variables. For example, if we just copy what we did in C#, B equals J, and C equals candy, and then D equals 13, and then E equals 7.77. Python will interpret all of these variables into their appropriate data type. And there are benefits to this. And to examine that, let's go back to C# for a second. Now, at the fact that you have to explicitly cast your data type in C#, the moment that you initialize that variable, it is stuck with that data type. For example, if I wanted to come down here and let's say, I don't want A to be a char, I actually want it to be a bool. Well, I couldn't do bool B equals true, for example. It would tell us that this variable has already been defined. So we can't recast data types of variables. Well, can we just reassign it to have a different type of data? And the answer is no. It will tell you that you cannot convert it from its original data type to a new data type. It's pretty much saying this variable already has a data type. However, in Python, because it's an interpreted language, we can do whatever we want with our variables. So for example, we can come down here and then say like, I want B to equal true. And it'll give you no errors whatsoever. And to prove this, I'm just going to write out a print function here. Print A, B, C, D, E. And you will see that we will get 2 trues for A and B. I'm going to save and hit the play button and voila. Now, although this data type free syntax seems pretty cool and whatnot, and don't get me wrong, it is really cool. It is a lot of flexibility, especially if you know how to use it right. But it can also cause some problems if you're not careful. A lot of the common issues that I was finding myself in the early days of learning Python with this data type free syntax was that I was never really sure what data type some variables were, and I was trying to use them in certain contexts, and it was just really messing me up. Another issue is that there's nothing preventing you from easily reassigning a variable when you didn't mean to. In C#, for example, they'll tell you if you already have a variable with that name in your script. And it'll also tell you if you're trying to change the data type for that variable, which both kind of act as a sort of security, if you will. But either way, both have their own pros and cons. It's up to you to decide which one is best for you. Moving along, one thing that I think is really important to touch on is assigning your variables after initialization. So in C#, you only have to cast the data type of your variable one time. In fact, you can only cast the data type of your variable one time. To demonstrate this, I'm just going to get rid of this line because I don't need it. And let's try and reinitialize our A variable as a bool with a false value. So I'm going to cast our data type. I'm going to do bool and then A equals false. And you can see here that it tells us that this variable has already been initialized. Essentially, that's what it's saying. And of course, what you're assigning to that variable has to be a value that is accepted by that data type. For example, Booleans only accept true or false, for example. And of course, in Python, because it's an interpreted language, this is no problem. We can simply just do A equals false. And we could also do B equals false if we wanted to. C equals false. And why stop there? We can do D equals false as well. And we can even do C equals false. Because this will all be interpreted when we run our script, which is now. I'm going to hit the play button up at the top and you'll see we get all false and a 777 because I didn't do E here. Sorry. E equals false, save, hit the play button, and there you go, all falses. It was interpreted as soon as you ran the script. And so that is the gist of variables. They're really easy to get your mind around. It's just, you just have to remember that these are pretty much containers that have some sort of data in them with a specific data type. So lastly, I'm just going to leave you with a simple example so that you can kind of get a better idea on how variables are applied and how they're useful. So imagine you're making some sort of game with the boss battle, and this boss can only take damage when it's either hurt, flashing, or dizzy. It has to be in some sort of state. So I'm just going to create the scenario. I'm going to remove all these lines. Don't need them. Start over. First, I'm going to initialize an int. I'm going to call it enemy HP. For example, that equals 50, and then get a bool in there. We'll call this hurt, and let's just say that it's already hurt, so hurt equals true. Get another boolean. We'll call it flashing. Flashing equals true, and then let's do bool dizzy. Let's say dizzy, and let's just say that it's not dizzy. It's not really important. I'm just gonna use if statements to create those states. If hurt, then we're going to do enemy HP minus equals 4, for example. And then if, I'm going off screen here, if, what else is there? Flashing. Oops. If it's flashing, then enemy HP minus equals 4. And lastly, let's see, if what, dizzy, then also enemy HP minus equals 4. All right, so just to explain what's going on here, it's just as I said, we have, let's say you're making some game with a boss battle, and the only way that the boss can take damage is if it's either hurt, flashing, or dizzy. Now, none of this is really important to the example that I want to create, but it at least gives you an idea of a scenario. So now imagine that you did some testing on your game, and you figured out that 4 is not enough damage to make the game fun. You need that damage to be higher. Well, you would have to go back into your script and change enemy HP minus equals, let's just say it's 7, enemy HP minus equals 7 again, enemy HP minus equals 7, and let's say that you had this reference to damage like all over your script. You have to do this as many times as you have that reference. And this is a use case where variables are very useful. So instead of having to do this as many times as you make the reference in your script, you could simply just come up to your variables up here and just initialize, let's say, a new integer, call it damage, and set it to 7. And then all you have to do is go throughout your script and just add a reference to that the integer you just initialized. So minus equals damage, and damage. So now let's say that you retested your game again and you're like, oh wait, on second thought, 7 is a bit too high. I need to bring it down a bit. Well, instead of having to go again through all of your scripts and changing wherever you make a reference to HP minus damage, all you have to do is now change one variable to, a lower number, let's say 6, and now all of these references are updated. And so now that your damage value is a variable, you now have a lot more power with it. You can come down, for example, to your dizzy state and say, like, just for example, if he's dizzy, then what I want to do is damage equals 3, for example. I just want to make it a lot weaker if it's dizzy. And this will be updated whenever it's flashing and you do this line or you do this line. And of course, I'll just quickly do this example in Python. Just going to get rid of everything. I don't need it. I'm going to do enemy HP equals 50, and then hurt equals true, and flashing equals false, and then dizzy equals false. I got that backwards. This is actually true. And then we have to do if hurt, then enemy HP minus equals damage. I guess we need a damage. I'm just go straight for the actual example. Minus equals 6, and then if what is it, flashing, then enemy HP minus equals damage, and if dizzy, dizzy And then damage equals 3. And why not? Just for fun, we can run this. I'll do at the end of it all, print enemy HP, just see what we get. I did not pre-calculate this. We get 38. Very nice. And then if we print this in C#, we should get the same result. I'm at a console.writeLine. And then what is this? Enemy HP. And then, oops, semicolon. Then we also need a console.readLine so the console doesn't close on us when we run it. I'm gonna hit the start button up here and then bring the console over, and you see that again we have 38. Very nice. And there you have it. Again, variables are pretty easy to conceptually understand, but they get a lot more powerful and a bit more complex when you start using different data structures like arrays and whatnot. But that's pretty much everything that you need to know to get started with programming in regards to variables. Alright, so an if statement is a type of conditional statement in programming, meaning it checks if a certain condition is met. An if statement in the most simplest terms is, if this, then that. In fact, if statements in programming are actually shorthand for if this, then that statements. One of the greatest lesser known fact that most people don't even realize with if statements is that if statements are essentially just booleans. They activate if something is true and don't if something is false. Now, remember that, because understanding that fact can save you a lot of headache when trying to debug your if statements. You simply just have to look at your if statement and ask, is this returning a true or false value? And honestly, it doesn't get any more complex than that. If you've ever asked someone an if question, you understand if statements. Now, let's look at how to write an if statement with code. And we're going to do this by using 2 different languages, because I think it can be really helpful for you to see how they compare and contrast. And plus, you'll pretty much learn 2 languages at once. So on the left is the language C# using the IDE Visual Studio, which should interest you if you want to do Windows development or want to make games using a popular game engine called Unity. And on the right is the language Python 3 using the IDE Visual Studio Code, which should interest you if you want to get more into general programming or data science. Alright, so here I have 2 brand new console projects, and if you don't know how to make a new console project in either C# or Python or both, be sure to check out the video in the description. It's called How to Install an IDE, and at the end of that video I'll show you how to do that. Alright, so today's lab is going to be really simple and really easy, because once I show you the Boolean secret with if statements, you're going to get it right away and you're not going to have any problems with if statements moving forward. So just as I mentioned, the secret that most people don't even realize with if statements is that they're really just Booleans that will run some code block if their value is true. But before we dig into that, let's first look at some of the syntax differences between C# and Python. Alright, so starting with C# over here on the left, I'm just going to get rid of these 2 lines because I do not need them. They come standard with any new console project. And I'm going to write out an if statement. And to do that in C#, first thing you need to do is just write out the word if, and then you want to add parentheses. And then inside these parentheses are where you want to put your Boolean. So I'm just going to put true. In C#, the true value is lowercase, and then under it, I'm just going to write out a start brace and an end brace. This is the code block that will run if our if statement is true. And there you have it. This is how you write an if statement in C#. From here, you can write any commands that you want in here. So you can do like, I don't know, console.writeLine if you want to, and then we can put hi. For example, you can put whatever you want, and so long as this returns true, this Boolean within the if statement parentheses is true, then this block of code will be ran. Now, before we move on to Python, I just want to mention one really important thing. If statements in C#, they have to have the parentheses, and the Boolean has to go inside of the parentheses. If you were to remove this, you can see that we will get a syntax error because if statements in C#, again, have to encompass the Boolean value in parentheses. Now, over in Python, the way that the if statement works is the exact same. However, the syntax is a bit different. To write an if statement in Python, we want to first write out the word if and then simply just put true. And the true value in Python is capitalized, so don't forget that. And then at the end, we have to end it with the semicolon. I just want to pause here and make this distinction. While yes, Python doesn't use parentheses, it uses instead a colon. And this colon is what tells Python that the Boolean for your if statement has been completed. And so moving along, to do the code block for your if statement in Python, it's a bit different than how C# does it. Again, the way that we indicate a code block in C# is we use the two braces starting in, and we put all of our commands in the middle of those two braces, all which are under the if statement. But in Python, instead, we just have to go to the new line and we use indentations instead of braces. So to give an example, in here we can just do like print and then hi. And there you have it. And so the next natural question to ask is, well, how do I add more commands to my if statement? Well, the answer is pretty easy actually. Anything that is under the if statement and is indented in will count within that if statement's code block. So for example, I'm just gonna hit Control-C, Control-V just to give you an example. So here are 4 different print functions that are all within this if statement's code block, because they all are indented in and they're all under this if statement. And so the next natural question to ask is probably something like, well, how do I exit this code block? I mean, I don't want my whole entire program to be dependent on this if statement. And the answer is, in Python, indentation rules over everything. So for example, if you want to exit out of this code block, all you would have to do is just come down and then return back to the regular indentation and just do print, I'm out, for example. And just to prove to you that this works as I say it does, I'm gonna hit the play button right here and you'll see that we get hi, 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 I'm out. And then I'm just gonna set this to false to let you see that we set this to false. This code block will not run. We're just gonna get printed I'm out, hit the play button, and right there all we have is I'm out. And another question you might have is, well, what about if statements within if statements, like nesting if statements? I think in C# it's pretty obvious how you do that. You would just write an if, another if within an if, and do another code block, and you can do another if you want to, and this can go on forever and never until you get tired. But in Python, it's probably not as obvious. But so I'll show you. So you just write within that code block, which again is indented, one indentation out. You just do another if statement, true, for example, colon, and then just another indentation. And you just keep this format going as long as you need to. And here we'll do another if statement. Print another hi. And that's all there's to it. And here's the very last thing that I'm going to leave you with. So in C#, I'm just going to get rid of all this just so it's a lot less confusing. In C#, when you have a code block, you can leave that code block empty if you want. You have no errors, no problems. C# won't complain. You'll be fine. But in Python, you can't do that. So if I remove all of these lines and just have our if statement, and then we will return indentation after the if statement, you can see if we go to our problems here, you see that we get an error for that. This is not allowed. You have to put at least something in there. So, you know, if you just want to write some if statement just to fill it out later, for example, you can just put a if you want to, which does absolutely nothing. And yeah, there you have it, guys. That's if statements for you. I just want you to remember our little secret. The condition that if statements checks for, they're only a Boolean. And again, the code block will run if the Boolean returns true, and it will not run if the Boolean returns false. And so with that, you can create some pretty intricate and complex Booleans, and then just put that Boolean right here in the if condition. From the most simplest program to the most complex program. That is pretty much how every program works under the hood. If you want to learn how to better use if statements, I highly suggest you check out the Boolean lesson that I did. In that lesson, I go over more detail on how to use Booleans in some real world situations, and then once you create that Boolean, you can just embed it in an if statement like this. And yeah, that's pretty much everything you need to know to get started programming in regards to if statements. So at the fact that you're watching a video on else statements, I'm going to assume that you know what an if statement is. Or in other words, an if this then that statement in disguise. But if statements alone are very limited. For example, say you build a robot to get lunch for you and you tell it, if they have spicy jack quesadillas, get me one. Your robot goes to get lunch, they don't have any spicy jack quesadillas, and so it returns without getting you anything. Now, you can't get mad at your robot because it did exactly what you instructed it to do. Very literally. Computers are very literal. But that is where an if statement's partner in crime, the else statement, comes in. Let's start with what is an else statement? Well, in the most layman's definition possible, an else statement is a conditional statement that will run if the initial condition is not met. And they are very important to programming. Going back to our example, an else statement would be the equivalent to telling your robot, if they have spicy jack quesadillas, buy me one. Else, give me anything. Your robot again goes to get lunch, they don't have any spicy jack quesadillas, that initial condition is not met, and so it gets you anything. And honestly, else statements don't get any more complex than that. They are pretty simple concepts to get your mind around. Now, let's look at how to use an else statement properly with code. And we're going to do this by using two different languages, because I think it can be really helpful to see how they compare and contrast. And plus, you'll pretty much learn two languages at once. So on the left is the language C# using the IDE Visual Studio, which should interest you if you want to do Windows development or want to make games using a popular game engine called Unity. And on the right is the language Python 3 using the IDE Visual Studio Code, which should interest you if you want to get into more general programming or data science. Alright, so here I have two brand new console projects, and if you don't know how to make a new console project in either C# or Python or both, be sure to check out the video in the description. It's called How to Install an IDE, and at the end of that video I'll show you how to do that. Alright, so just like the if statement lab, this else lab is going to be pretty quick and easy because there's not much to it. So how do we use an else statement? Well, the first thing that's important to know is that else statements are completely useless without an if statement. They are 100% dependent on an if statement. To demonstrate this, over on the left in C#, I'm just going to get rid of these two lines because I don't need them. They come standard with every new console project. And then I'm just going to write out else and then our code blocks. But you can see that we have an error. But syntactically, we did everything right as far as syntax is concerned. So what did we do wrong? Well, again, else statements by themselves are completely useless. They need an if statement to depend upon. So to fix this, I'm just going to come above the else statement and write if, and then let's actually do false, and then our code blocks, and then there you have it, fixed. As you can see, we're getting no errors, we have no issues, everything is fine and dandy. So let me explain this relationship that we have going on here. So you have your if statement right here, and this code block is only going to be ran if the boolean inside the parentheses is true. But at the fact that we set it to false, it's going to go down and do this else statement. So in other words, if this statement is true, that means whatever's inside this parentheses, if this returns true, then run this block of code. Else, run this block of code. As simple as that. And to demonstrate this, I'm going to write to the console. So I'm going to use console.writeLine. And then here I'm going to put plan A. And then I'm going to come down here in the else and then write console.writeLine, and I'm going to do plan B. And then of course I need to add a console.read key just so that the terminal doesn't close on us until we press a key. And then just for demonstration purposes, I'm going to change this to be a true value. Then I'm hit the start button up here and bring the window over right here, and you can see that it prints out a plan A. And again, very intuitive. The reason is because we said if true, which if this whatever is inside the parentheses is true, which we said is true, then it's going to print out this. And at the fact that it's true, it ignores everything after that. Now let's say that our if statement boolean returns a false value instead. Well, remember the logic. This is checking if whatever's in this parentheses returns true, then run this code. Else, if it doesn't, then run this code. And you can see that Visual Studio, the IDE, is giving us a little heads up that this is not going to be reachable because it's kind of, they kind of put the alpha down a bit. It's a bit darker than the rest of the code, which is a nice little heads up from the IDE. And just to demonstrate that this works, I'm gonna hit the start button and bring the console window over, and you can see that it prints out plan B, just as we expect. And now over in Python, the else statement works the exact same. However, of course, the syntax is a bit different. And just like the else statement in C#, we can't just write an else statement by itself in Python either. So just for example, I'm gonna put a 0 and then hit the play button, and you can see that it returns a syntax error. And again, the reason for this is that else statements need to depend on an if statement. And so I'm just going to come above the else statement and then write an if statement. I'm just going to say if false, and then I'm going to print out what, I'll just do 1, I guess. And then you can see that I used the wrong false. That is false for C#, false in Python, and true in Python are both capitalized. Trips me up all the time, but there we fixed our else statement error. And just to make this look just like the program that we did in C#, I'm going to write plan A here, and then I'm going to write plan B there. And again, you can use single or double quotes for Python. It doesn't really matter, but just to make it look cleaner, I'm going to use double quotes for both. And of course, if I change this to a true value, then it's going to give us plan A when I hit play. Oh, I got to, of course, do print plan A. My mistake. Let me just change this real quick. Print plan A and then hit play. And you can see that we get plan A and not plan B. And of course, if we change this back to false and then hit save and then hit the play button, you'll see that we get plan B instead. Because again, it checks if this statement is true, do this block of code. Else, do this block of code. Simple as that. And the final thing that I'm going to leave you with is that you can only have one else statement per if statement. For example, if you come down here in C# and do if this statement, run this block of code, else run this block of code, and then we try and do another else, you can see instantly we get a syntax error, because even if you think about the logic, this makes absolutely no sense. You're saying if this is true, then run this is true. Or else just run this, and then or else run this. That it just logically doesn't even make any sense. So that's why you can't do it. And of course in Python we can't do two else statements back to back either. I'm just gonna type else and then print plan, gosh dang it, plan C, save, hit run. You can see that we get a syntax error because it makes absolutely no sense. And yeah, there you have it. Else statements are pretty handy when paired with if statements. And of course, your if statements are just regular if statements. Inject booleans in there and make some really powerful logical operations. And there is everything that you need to know to start programming in regards to else statements. Alright, so you have if statements and you have else statements, but you also have else if statements. So starting with the first obvious question, what is an else if statement? Say you build a robot to get lunch for you and you tell it, if they have spicy jack quesadillas, get me one. Else, give me anything. Your robot goes to get you lunch, they don't have any spicy jack quesadillas, and so it returns with getting you a cheeseburger. But you realize that the restaurant doesn't serve french fries. And now you wish that you had something different, because what's a cheeseburger without fries? And so to correct something like this, you can bring in an if statement's other partner in crime, the else if statement. So how does it work? Going back to our example using the else if statement, you could tell your robot, if they have spicy jack quesadillas, get me one. Else, if they serve french fries, get me a cheeseburger. Else, give me anything. And with this program, you can send your robot to any restaurant and be sure it'll get you what you want if the conditions are right. Because if statements are pretty much just booleans, they're essentially like backup if statements. And that's pretty much all there is to an else if statement. Now, let's look at how to use else if statements properly with code. And we're going to do this by using two different languages, because I think it can be really helpful for you to see how they compare and contrast. And plus, you'll pretty much learn two languages at once. So on the left is the language C# using the IDE Visual Studio, which should interest you if you want to do Windows development or want to make games using a popular game engine called Unity. And on the right is the language Python 3 using the IDE Visual Studio Code, which should interest you if you want to get into more general programming or data science. Alright, so here I have two brand new console projects, and if you don't know how to make a new console project in either C# or Python or both, be sure to check out the video in the description. It's called How to Install an IDE, and at the end of that video I'll show you how to do that. Alright, so just like the else lab, the else if lab is going to be pretty quick and easy because again, there's not really too much to this. So how do we use an else if statement? Well, just like an else statement, an else if statement is completely dependent on an if statement. Without an if statement, an else if statement is just completely useless. And to demonstrate this, over here on the left in C#, I'm just going to remove these two lines because I don't need them. They come standard with any new console project. And I'm just going to write else, and then if, and then true, and then my code block. And as you can see, we get an error because this is invalid syntax. Again, else if statements are completely useless without an if statement. And over in Python, it's the same exact thing, except for the syntax for else if statements is just a little different. So instead of else if typing that out explicitly, you just type ELIF, else if, it's shortened. And then you can just put true here, and then your colon, and then your logic. But even if I were to put some logic here, let's just say I'm going to put 0, you can see that we get an error. I'm going to hit play, and it tells us that this is invalid syntax. Again, the else if statement by itself is completely useless. And so to fix this, I'm just going to come right above our else if statement and add an if statement to that. So if true, then we go on to do console.writeLine, and then we're going to say plan A. And then I'm going to come down here and do the same console.writeLine, and then plan, if I can spell, plan B. Semicolon, boom. I'm just going to do the same thing in Python so that they are on the same spot. Let's see, true. Then we want to do print plan A. And remember, indentation is really important, so we're going to come back down here, and then else if that's true, then we want to print plan B. And so what is all this saying? Well, this is saying if this statement is true, then run this block of code. Else, if this statement is not true, but this statement is true, then run this block of code. And over in Python, it works the same exact way. So we have if this statement is true, then run this block of code here. Else, if this statement is not true, but if this statement is true, then run this block of code. One difference I want to point out between the two for the else if statement, it's a minimal difference, but Python really prides itself in being like optimized in every way possible. And that includes like how many characters you have to type for else if. This is only 4 versus over in C# you have to type 7, including the space. Again, it's minimal, but differences are differences. Now here is where the real power of else if statements comes into play. What makes else if statements so useful is that you can add as many else if statements as you want. There are no limits. So if I come over here and just grab this and then hit copy and then paste and then paste and then paste, you can see that we have no errors, there's no problems, no issues. You can do this as many times as you want. In Python, there's no difference. You can grab this, copy and paste, for example, and do this as many times as you want. Though do be careful with your indentation. Make sure that your indentation is always correct. And so with that, I think it's important to touch on the order of operation and how important that is. So with any if statement tree, it always will first check the first one. If the first one is not true, then it'll go to the next one. If the next one's not true, then it'll go to the next one, and it'll keep on going down the line until it gets one that is true. So say for instance, this one is true, then it's going to run this block of code and it's going to exit out. It's never going to even touch this else if statement right there. And I can demonstrate this for you. I'll just change this to plan C, change this to plan D, and change this to plan E. And let's say that the Boolean check here returns a false, And then let's say this one also returns a false, and so does this one right here. Well, what we should expect is that it's going to check this one, get a false, else if check that one, get a false, else if check that one, get a false, else if check this one and get a true, and then it'll run this block of code and should print out plan D. And just to prove that, I'm going to hit the start button, and then I'm going to bring, we forgot to add a console.read key so that the terminal doesn't close until we press a button. And then I'm going to hit the start and then bring console over, and voila, we have plan D just as we expected. Now, of course, this also works in Python, and I can prove that to you. Just going to change this to C, D, E. Did I mess up? A, B, C, D, E. Oh, I guess I made one over here. Either way, E, F, and then we can set this one to false, and then we can set this to false, and then we can set this to false, and we should expect again to get to print out plan D. Gonna hit the play button, and we see a plan D. And the last bit of information I think will be useful for you to know is how to incorporate the actual else statement. So let's say that you have some variable, right? You have like a money variable, and you have this first statement. It's like, if I have over, I don't know, $1,000, then do this block of code. Else, if I have over, let's say $750, then run this block of code. If I have over 500, run this one. If I have over 250, for example, run this one. If I have over 100, then run this one. And let's say that you have to print to the console something, right? Well, if you do all these checks and you have $0, then you'll never print anything. But that's where the else statement comes back into play. All you have to do at the very end of your if statement tree is just simply add else. I want to do a console.writeLine plan, what is this, EF, plan F. And that is all you got to do. Now take note, your else statement has to be at the end of your if statement tree. It can't be anywhere else but at the very end. I mean, even if you think about it logically, that's the only thing that makes sense. And that's pretty much everything to else if statements. The final thing maybe to note is that else if statements are no different than if statements. Like this and this are the same exact thing. The only difference is that an else if statement is dependent on an if statement. You remember that simple rule and you'll have no trouble using else if statements. And that is everything that you need to get started programming in regards to else if statements. For loops. It's time to learn all about for loops. Now, these are a very essential thing for any programmer to know. So what is a for loop? Well, simply put, a for loop is a shortcut to run a block of code a certain number of times. So say you have 4 phone numbers, for example, and you want to add an area code to each of them. Well, instead of hard coding this 4 times, phone number 1 plus equals area code, phone number 2 plus equals area code, phone number 3 plus equals area code, etc., etc., you can just use a for loop and write out the logic one time to get the same job done in less lines of code. And for loops are very powerful in this regard because they scale quite well. So 4 phone numbers isn't that bad. You could write out phone number 1, 2, 3, 4 plus equals area code pretty quickly. But now imagine instead of 4 phone numbers that you want to add area code to, imagine that you had 4,000 phone numbers. You can imagine how redundant it would be to have to write out phone number 1, 2, 3, 4, 5, 6, 7, 8, all the way to 4,000 plus equals area code 4,000 times. So let's take a look at how we can use for loops to do amazing things like this. And we're going to do so by using 2 different languages because I think it can be really helpful for you to see how they compare and contrast. And plus, you'll pretty much learn 2 languages at once. So on the left is the language C# using the IDE Visual Studio, which should interest you if you're interested in doing Windows development or want to make games using a popular game engine called Unity. And on the right is the language Python 3 using the IDE Visual Studio Code, which should interest you if you want to get into more general programming or data science. Alright, so here I have 2 brand new console projects, and if you don't know how to make a new console project in either C# or Python or both, be sure to check out the video in the description. It's called How to Install an IDE, and at the end of that video I'll show you how to do that. Alright, so for loops. For loops are extremely useful tools in programming, so let's jump into it starting with some syntax. Now, the syntax for loops in C# can be a bit tricky to remember, but it's not terribly hard. You only have to remember these 3 things. But first, I'm gonna remove these 2 lines because I don't need them. They come standard with every new console project in C#, so we can just get rid of them. And this is what you have to remember. I'm gonna write this in a comment just so that it's easier to remember. So a couple of forward slashes for that. And so first you write the word for, and then parentheses. And now in these parentheses, this for loop happens in 3 steps. So let's segment it by adding 2 semicolons. And at last, the first thing you have to memorize is to initialize your variable. I'll just shorten this to initialize because we were going to quickly run out of room. And then the second thing you have to remember to do is to set your condition. And the final thing you have to do is give a command. So long as you remember these 3 things, for loops will be really easy for you to remember. So now let's walk through an example on how to initialize a for loop for real. I'm just gonna come down here to the next line and I'm gonna write out the word for. And then the first thing I need to do is initialize a variable. Now, the most common variable that most people initialize at this step is actually an integer variable called I, and you assign usually 0 to it, but you can assign whatever you want to it. Actually, you can initialize any variable of any data type that you want here, but we'll come back to that in a bit. And so the next thing we have to add here is the condition, which simply just asks how long do we want this for loop to run. And this condition here in this space is actually just expecting a Boolean. And so let's write a Boolean in here. Let's say that we want to run so long as I is less than 10. Sounds good enough to us. And then the final thing we need to add is the command. And with the command, we simply just instruct our computer to do something. So if we initialize an integer named I and assign 0 to it, and we're saying that we want this for loop to run so long as I is less than 10, then here we can say we want I for every time the loop finishes to simply just add 1. Using the increment operator, it just adds 1 to whatever variable we added the increment operator to. And then at last, we just come down here and add our code block for the for loop. And now every single time that this loop goes through, it's going to run everything within the code blocks, which again is everything that we add within these 2 braces. And then at the end of it, it's just going to come back to the top. And then when it comes back to the top, it's simply going to check our condition here. It's going to ask, is I less than 10? If true, then it's going to exit here. It's no longer going to run this loop anymore. It's going to go to whatever line is right after that. But if false, then it's going to do our command here. And then it's going to again run this block of code and continue that until when it checks here and this is false, then again, it's going to exit and run whatever line comes after the for loop. And so now to do a for loop in Python, it's actually a lot different. Python doesn't have this syntax where you initialize a variable and then you set a condition and then you give a command. It's actually, in fact, probably a lot more simpler, but the syntax for it goes as follows. First, you want to type out the word for, and then you want to type out I for I in, and then you need to define a range. And let's just say 10. We're gonna use the same 10, and then you write your colon here to start your code block, and then here you can put whatever commands you want in there. Now that's how you initialize a for loop in both C# and Python. However, I want to go back to the C# initialization real quick and point out something really interesting. Now, I think in most cases for loops with this syntax, you'll find that most developers will first initialize an int called I and then assign it to be 0, and then do like if I is less than a certain number, then we're just going to use the increment operator on it. But I want to relinquish your mind early in development because this right here is the actual rules for a for loop. But to understand where I'm about to go, I think I need to first show you what's going on with a traditional for loop. So I'm going to do console.writeLine here, and then we're just going to print out the value of I. And then of course down here I need to write a console.readKey. so that the terminal doesn't close on us as soon as we run it. I'm just gonna come up here, hit the start button, and then I'm gonna bring the console window over so you can see what we have going on here. So as you see, I is initialized and assigned to 0, and then we increment all the way until I is no longer less than 10, and then we exit out the for loop. Pretty simple. But again, here it says initialize. So we can initialize whatever we want actually. This doesn't have to be an int. We can initialize a float if we want to. Run it again and you can see that we have the same exact result. But why stop there? Instead of using the increment operator, we can do plus equals 0.5 if we want to. Hit the start just to show that result, and you see that we zeroed, then we increment +5, and then another +5 all the way to 9.5. And of course, that's not all. We can initialize a string if we want to and assign that to equal empty string, and then here our condition as long as I, and then we can grab the length by hitting dot length of the string is less than 10, let's just say. Then we want to do I plus equals let's say Z, for example, and then we can run this for loop here. Start button, bring the window over, and we can see that it creates this interesting for loop. The sky's the limit, so long as you follow this convention right here. And because Python doesn't have the syntax, you can still achieve it, but you'd have to achieve it in other creative ways. Also, I didn't prove it to you that this works in Python, so I'll do that really fast. I'm going to do print and then I, and then I will run this by hitting the play button. You can see that it prints out all the digits in the range of 10. Now, that's pretty much how you go about using for loops. Now, as far as how you go about applying for loops, that's your own creative problem-solving endeavor that I'll let you figure out on your own. However, I will leave you with one use case. So I went ahead and wrote out the program for our scenario because otherwise it would have been a long silence watching me type this out, but I'll walk you through it. But first, imagine that you've collected 700 files with a bunch of candy data on it. And now that you have this data, you need to get it all in one place. Now, you could open up one text file and manually add it to the other, then open up another text file and manually add it, and then next, and then add, and next, and add, but that's even exhausting for me just saying it verbally. You could instead write a program with a for loop to do this for you. And so first, we initialize a few variables. First one is a string array with all the file names on it. And then the next, we have the master data string, which we're going to compile all of our data to. And over in Python, we do the same exact thing. We initialize a string array called file name with 700 files that can fit on there. And then our master data string that will compile all of our data onto. And then we come down to our for loop in which we initialize an integer named I, assign 0 to it, and then we have our condition here, which pretty much just says so long as I, which is the location in our for loop, as long as that is less than the amount of files that we have in the file name string array, then we want to continue looping. And then of course our command, we just want to increment the integer I. And then down here in the code block, all of this is kind of fake. I just made it up for the scenario, but there is a huge assumption happening here. I'm assuming that you as the data collector, you are really good at naming your data files. And so every single data file that you have is named candy space data space and then whatever number of data file that is .txt. Very important. Because if your data files are named something a bit more chaotic, then we lose the power to use a for loop on it. So let's just say that you're really good at naming your files like this. Oh, and just to clarify, this $ means that this string is interpolated. This is an interpolated string. If that's confusing, check out my string lesson. I go all in depth into it. But anywho, what we're doing here is we are taking the file name array at the element of I, which is where we're at in the loop, and then we're just going to assign this file name to that location or that element in the file name array. And then on the next line, I made a fake function here where it takes in the name of the file name and it's supposed to read data, but down here it doesn't do anything but just return so like some string with the actual data name. But this is a real function. It exists in a lot of libraries, but it's beyond the scope of this video. So just know that this right here represents something that really does happen. And so we pass the file name through the read data function. The read data function will open up the text file, read whatever is on there, and then we will add that to our master data string. And then over in Python, we do the same exact thing. We have a for loop here for I in range length of file name. Just to break apart what this means really quick. So length function, it returns the number of items in a container. And so this file name is a list with 700 items in it. So when we run length of file name, it's going to return 700. So for I in range of 700 will be our for loop. And then we come on down into our code block, and here again we have our file naming convention that we're just going to assume that you're good at labeling data. Every file is named candy data and then whatever the number is, but it doesn't start at 0, it starts at 1, so we have to add 1 to our I because I does start at 0. .txt, and then we just assign that to our file name list at the element of I. Again, that loops from 0 all the way to 700. And that's going to match up because they're both using I's here and here. And then finally, we made a fake function called read data. It doesn't really do anything except for return candy data from and then whatever the name of the file is. But we will run that function, pass in the file name, and let's say this was a real world scenario, then this would open up whatever that text file is, grab the data from that, and then we would add that to our master data string. And then finally, we just come down here and then we'll print the master data. And just to prove that these work, I'm going to come up here and hit the start button in C# and bring the window over, and you can see that we have all this candy data. Look at all that candy data. Wow. Then I'm come over here in Python and hit the play button and error. Oh, right. So Visual Studio Code has a really weird, well, it's not weird, it's helpful, but if you have something selected and you hit the play button, then it's just going to run that. So I'm going to select nothing and then hit the play button, and there you go. You can see that it generates all that data. Wow. And yeah, there you have it. This is one creative use case in which for loops can be really helpful. But there are a ton of different for loop use cases, but it would take me all day to sit here and list out a bunch of different ones. But you now know how to write your own for loops. So now you can think of really interesting ways yourself to apply for loops. And that is everything that you need to know to get started with programming in regards to for loops. Let's talk about while loops. While loops are a type of loop, obviously, and they share a lot with a for loop, except instead of running a block of code a number of times, it runs a block of code while a certain condition is true, hence the name while loop. You'll find that while loops are a lot less common than for loops, but every once in a while you'll find the perfect use for while loops over for loops. For instance, when I make any sort of robotics project, I find while loops very handy to use. Anywho, let's take a look at how to use while loops with code, and we're going to do this using two different languages, because I think it can be really helpful for you to see how they compare and contrast. And plus, you'll pretty much learn two different languages at once. So on the left is the language C# using the IDE Visual Studio, which should interest you if you want to do Windows development or want to make games using a popular game engine called Unity. And on the right is the language Python 3 using the IDE Visual Studio Code, which should interest you if you want to get more into general programming or data science. Alright, so here I have two brand new console projects, and if you don't know how to make a new console project in either C# or Python or both, be sure to check out the video in the description. It's called How to Install an IDE, and at the end of that video I'll show you how to do that. Alright, so while loops. Now, today's lab's going to be pretty short because there's not really a lot to while loops. But let's start by looking at the syntax for a while loop. In C# over here on the left, I'm going to get rid of these two lines because I don't need them and they come standard with every new console project. And I'm simply going to write out while and then in parentheses true and then our code block. This is the syntax for a while loop in C#. You essentially just write while, and then you have to pass in a boolean here, and then you have your code blocks where you can put all of your demands that will continue running over and over and over while this boolean is true. And over in Python, a while loop looks like this: while, and then true, and then I'm just going to put pass here in our code block. Pass just pretty much means don't do anything. And this is the syntax for a while loop in Python. Pretty simple. Now, one extremely important thing that you need to know about while loops is that while a while loop is running, whatever comes after the while loop. So if I come down here, for example, and do a console.writeLine, for example, and then reached, for example, anything that comes after a while loop will not be reached until the while loop has been completed. And again, the reason for this is because when you run a while loop, it just runs whatever the code is in its code blocks over and over and over. However many lines there are, it goes one by one by one, and then once it reaches the end, it starts over at the top and continues going until this Boolean value here is no longer true. Once this is false, then it will stop doing its loop and then go to the next lines after the while loop. And this process also happens in Python. If I just come down here and do print and then reached, for example, this while loop will keep on doing every single line in its code block until this condition here is false. And if it's never false, then guess what? This code right here will never be reached. And I can prove that. But first, I need to set up a couple of variables. I'm going to come up here and then I'm going to initialize an integer. Let's just call it a, why not? And we'll set it to equals 0. And so within this Boolean value, all we have to do is say if a is less than 100, then we want you to run. And then every single time that you run, we can simply just do a plus plus, use the increment operator. And then let's also do a console.writeLine and just print out the actual integer value. And so what's going to happen here is that when our main program is ran, it's going to go down the line and then hit our while loop. And because a is less than 100, it's going to run this block of code one time, plus to a, and then write it out. And then it's going to reach the end and do it again, and then again 100 times until a is no longer less than 100. Once it's greater than 100 or equal to, then this will no longer run, and then it'll go to our write line reached right here. And we can print it out and I can prove it too, but first I need to come down here and do a console.read key. This so the terminal doesn't close on us when we hit the start button up here. And I'll bring the window over, and as you can see, we get results that we expect to get. The while loop will run over and over and over until its Boolean condition is no longer true. And once it's false, then finally the while loop will exit, it goes to the next line, and then on that line after it, we have the printout reached, which there it is at the end of the while loop. And over in Python, this is done the same exact way, just in the Python syntax. So to set that up, I'm simply going to come up here. Oops, what did I just do? Oops, I think collapsed that. Okay, come up here. I'm going to do a equals 0. And then while a is less than 100, then instead of pass, we're going to print just whatever a equals. And so now to prove that they work the same, I'm going to hit the play button up here. And as you can see, we have, we forgot to increment. Right. I'm simply going to increment a up here to a plus equals 1. And now our code should be fixed. I'm at the play button and bada boom. There you have it. Same exact scenario as in C#. And finally, there's one more way that you can go about stopping a while loop, and that's by using the break statement. So first question, what is the break statement? Well, the break statement is a statement that can only be used with loops, like for loops and while loops. And when you use the break statement, all it does is just breaks that loop, moving on to the next line after the loop. So to demonstrate this, I'm going to replace this Boolean right here with just a regular Boolean true value. And then I'm going to go into here and write an if statement. So now I'm going to say if a is greater than or equal to 100, then what we want to do is break. And to prove this works, I'm going to come up here to the play button, hit start, and then bring the window over. And you can see that it works exactly the same as the other method. And to do this method in Python, I'm simply going to replace this Boolean with the true Boolean value, and then going to come down here and do if a is is greater than or equal to 100. 100. Then we want to break. Gonna hit that play button up here to prove that it works, and you see that we have the same exact thing. Probably didn't even notice that it changed. And that's while loops for you. They can be handy in certain situations, but to be honest, you'll probably more often be using for loops. And there you have it. That is everything that you need to know to get started with programming in regards to while loops. It's finally time to talk about methods. So methods are amazing programming tools that, simply put, allow you to not have to repeat code over and over and over, and to be able to get a better grasp on your code. For instance, say you have some inventory class, and in this inventory class, you have a few things that can happen. You can close the inventory, you can open the inventory, you can empty the inventory, just to give a few examples. And instead of having to change a list of inventory variables every time you want to do these things, you can just wrap all this code into a method and just call that method whenever you want to do it, saving you a lot of time from writing the same code over and over and saving you from future headache. So now, let's take a look at how to use methods with code. And we're going to do this using two different languages, because I think it can be really helpful for you to see how they compare and contrast. And plus, you'll pretty much learn two languages at once. And so on the left is the language C# using the IDE Visual Studio, which should interest you if you want to do Windows development or want to make games using a popular game engine called Unity. And on the right is the language Python 3 using the IDE Visual Studio Code, which should interest you if you want to get into general programming or data science. Alright, so here I have two brand new console projects, and if you don't know how to make a new console project in either C# or Python or both, be sure to check out the video in the description. It's called How to Install an IDE, and at the end of that video I'll show you how to do that. So before we can use methods, we first have to learn how to initialize them. So let's take a look at their syntax. First, over here on the left in C#, I'm just going to get rid of these two lines because I don't need them, and then I'm going to come down here so that we can initialize a new method. And the syntax for that goes as follows. You simply just type out void and then whatever name you want for your method. I'll just call it ABC for example, and then you need to put a start in parentheses, and then finally simply just add a code block. And now you can put whatever commands you want within this code block. For example, I'm just going to put console.writeLine and pizza, because pizza is the best. And there we have initialized a method. Now to do this in Python, it's just a little different, but the concept is still the same. So to initialize a method in Python, you want to type out, instead of void, you want to type out def, and then whatever name for your method. We're just going to call it again ABC, and then you want to do your start in parentheses. This convention stays the same, but instead of going to a new line and doing code blocks using the braces, you simply just use a colon here and then go to next line and make sure that it's indented. I'm using the Visual Studio Code IDE, which automatically adds an indent for me when I go to the next line. But now, just like in C#, I can add whatever commands I want in this code block. So I'm going to write out print and then again pizza, because pizza is the best. So that's how you initialize a method in both C# and Python. But without more context, I don't think they're that helpful. So let's take a step back and examine a scenario. So imagine that you're writing some sort of program with an inventory system that has 3 spaces. And this program requires you to swap out what's in those 3 spaces quite a lot. So just to make this less confusing, I'm going to get rid of our initial examples on both Python and C#, and now I'm just going to pretty much set up that scenario with some variables. So I went ahead and wrote the scenario off screen because otherwise it probably would have been about 5 minutes of silence, but I'll walk you through it. So up here we have all of our string variables. This is our inventory, standing for INV. Slot 1, 2, and 3, Python has the same, and we first set them all to be empty. And then we have a couple of items we can pick up under the variable name pickup 1 and 2. The first one is pizza, because pizza is the best, and then we have candy. And of course, Python has the same exact thing going on there. Next, we just have a couple of if statements to kind of simulate an event happening. Let's say that you want to pick up some items. Well, first you want to check to see if it's empty, and then if it's empty, then you pick it up. Same thing happening here in Python. Okay, so we have our scenario all set up. I'm just going to come down here and add a console.writeLine just so we can print out the results here. Let's print out first inven1, And then I'm lazy, I'm just gonna do Control C, Control V, copy paste a couple more times, and print out also invin2 and invin3. And I'm of course gonna come over here in Python and do the same exact thing, except for the syntax a bit easier in Python. I can just do invin1, where we at there, and then comma invin2 and comma invin3. A much more simplistic print function Python has. Now, before we run it, what should we expect? Well, again, all of our inventory slots start off as empty, and then we come down here and do a check. If the first slot is empty, then we're gonna assign the pickup 1 to inventory slot 1, which is pizza. And then we do another check. If inventory slot 3 is empty, then we'll assign the pickup 2 to it, which is candy. So what we should expect is pizza, empty, candy. Let's see if we get that. Just gonna come up here and hit the start button. Oh, that's gonna close on us. I forgot to add, of course, console.read key. All right. So again, I'm just gonna come up here and hit the start button and bring the window over, and you can see that we have in our inventory slot 1 pizza, slot 2 empty, and slot 3 candy. Perfect. Gonna run that in Python as well. Hit the play button up here, and you see we got pizza, empty, candy. Perfect. Okay, so this isn't bad. This is pretty straightforward, does exactly what we want. But now imagine the scenario where when you assign a new item in your inventory, it doesn't only just change that item slot, maybe also, you know, it does some UI stuff here, and then it does like some special effects. What is that? I'm gonna say VFX, and then maybe it like updates other, like update slot 1, for example, inventory slot 1 also updates inventory slot 2, for example. And this happens for every time that you want to do this, right? So I'm gonna copy this and bring this down here, and you can see that our code is starting to get long and kind of strenuous. Now this is where one of the use cases for methods come back into play. The first advantage to using methods is having the ability to compress your code. Now, why would we want to do that? Well, everything within the code blocks of this main function right here is our main program. And over in Python, just for comparison, every line in the script counts as your main program. But as you add more code and the main program gets longer and longer, it can become more and more confusing and difficult to read and understand. And so instead of having this chunk of code or this chunk of code, we can convert that into a method and just call that method in our main program. And so let's do that. And to do that, I'm first going to come up to our first chunk of code and essentially encapsulate it inside of a method. So right above it, I'm going to add a start brace, come to the bottom of it, add an end brace, and Visual Studio automatically reformats to it for me. Thank you, Visual Studio. And then I can simply add our void, and then we can now get to the hardest part in all of programming. Now we have to name our method, which thankfully I thought of all this ahead of time, so you don't have to watch me struggle, but I'm gonna call it pickup pizza I1. And then of course our parentheses, close it out. We already did our code block ahead of time, and there you go. We have converted this to a method successfully. Now I'm just gonna do the same thing for our second chunk of code, just a bit different in my process here. Pickup, what is this, candy, and I3. Do that. Oops. I'm gonna get rid of this and then move this to the bottom. Automatically reformats. Thank you, Visual Studio. And there we have it. And over in Python, again, let's say that when you pick up something, you also do like some UI stuff and some visual effects, and you also do, you know, you update whatever information you need to update in slot 1 of your inventory, and you also update whatever's going on in slot 2, for example, so on and so forth. I'm just going to copy this and bring this down to this one as well, fix the format a bit, and you can see the script got a lot longer. So let's convert those into methods. Now, you already know the syntax for methods in Python. We simply just replace void with def, and then we name our variable. It's going to be pickup pizza, inventory slot 1, starting in parentheses, and then our semicolon. And then we have to come down to all of this and then hit the tab button so that this counts as a code block for that method. And then let's do the same exact thing for our second chunk of code. Def, what is it, pickup candy, inventory 3, starting in parentheses, and then our colon, and then come down to all these lines and indent them in so they count as a code block for this method. Now, we need to pause. If you take a look at our inventory 3 variable and even our inventory 1 variable, they are underlined red, which means that we have a problem. If we come down to our console and press problem, we see that it's telling us that these variables are not assigned. What's going on here? Well, this has to do with something called scoping, and Python is very peculiar about your scoping. To simplify, this block of code is self-contained only within this method pickupPizza inventory 1. It doesn't have any reference to anything outside of this code block. And of course, same goes for this code block as well. So one simple thing we can do to let these code blocks know that there is a variable called inv1 outside of its scope, which again is this, we can simply just come at the top of it and then type global and then inv1. Same down here, we can type global and then type inv3. And you can see our problems are gone. Problem solved. What we can do now to compress our code is grab all of these lines here, which contain both of our methods, and I'm going to hit Control X or cuts, and I'm going to now move this to the bottom of our entire program at the very end. And do you realize what just happened? Pretty much our program ends here. So everything before that is our actual program. Look how much shorter that is. And over in Python, we can do the same exact thing. I'm going to select all these lines that have our two methods here, hit Control X or cuts, and then I'm going to move that up. And then underneath our print function, I'm going to hit Control V or paste and put that underneath. And again, right here, our program ends here. Much shorter. However, our code is now compressed, yes, but we aren't completely done yet. Over in C# on the left, you can see that if I hit the start button up here on top and bring the window over, you can see that our entire inventory is still empty. And the same goes for Python. If I hit the play button, you can see that we have empty, empty, empty. And the reason for that is because at no point did we call our methods. And to do that in C# over here on the left, all you have to do is simply just write out the name of your method. So our first one, we want to do pickupPizza for 1. And then you also need to include your start and end parentheses. This is what denotes that it's a method. And then we need to do pickup candy inventory I3, starting in parentheses, and then our semicolon. And to prove to you that this works like I say it does, I'm gonna hit the start button and then I'm gonna bring the window over, and you can see that they have now been set. Check that out. Now over in Python, it's actually quite different, although the concept is still the same. So earlier, I moved all of our methods to the bottom of our Python script. But if we were to come into the middle of our program and then type out pick up, pizza item 1, and then start in parentheses and then run our program, you'll see that we get an error because pickup pizza item 1 is not defined yet, or inventory 1 rather, is not defined yet. And so a truth about Python is revealed. Using methods in this context isn't really all that useful because the order of operation is extremely important in Python. So to use our methods, we have to initialize them before we call them for the first time in our scripts, but also after we initialize the variables that we're using within them. And where is that sweet spot, you ask? Well, it's right here. And so I'm just going to select all these lines that contain our methods, and then I'm going to hit Control X to cut and then Control V to paste. And there you have it. And just to prove that everything is exactly where they need to be, I'm going to hit the play button up here in Visual Studio Code, and you can see that we get pizza empty empty. Hold on, that's not right. Of course, the reason for that is we have to call the second pickup as well. Pick up candy I3, start in parentheses, hit the save, then the play button, and voila, we got pizza empty candy. Okay, so that was one use case with methods, but I want to show you another one. I'm going to start by removing all the code that we did in C# and Python so that we can set up a new scenario. Bada boom. Now, imagine that you have some program with some sort of boss battle in it, and every time that you successfully hit the boss, 2 things or more happen. So I'm just going to quickly code up this scenario. Alright, so I went ahead and coded up the scenario off screen because otherwise there would have been another couple minutes of silence, but I'll walk you through it. So here we have a few integers initialized. We have my HP, the enemy HP, and some money. Then we have some booleans to check if we hit legs, arms, or head, set them all to be true. And then we simply have some if statements to check for those booleans. And if any of them are true, then we simply will minus HP from the boss and then add some money to our bank account. And Python does the same exact thing, same variables, my HP, enemy HP, and money, and then some hit legs, hit arm, and hit head booleans, and then we simply check those booleans, and if they're true, then again we're going to minus HP from the enemy and add some money to our bank account. And that's all it's to it. And so the next advantage that methods could give you is reducing repetition. If you haven't already observed, in both scripts we have this chunk of code right here. Enemy HP minus equals 1 and money plus equals 5. And this is repeated over and over 3 times each on both scripts. And I mean, that's fine and all. I mean, this will do exactly what you expect it to do. However, we have this rule in programming, and it goes as follows. Never write the same code twice. In addition, imagine that you want to add something else to these hit events. Like, for example, let's say that you wanted to take your HP and add a little healing for every successful hit, right? So you would come down here and do my HP plus equals 2, for example. But the problem is that you now have to write this for every single hit event. So my HP plus equals 2, go to the next one again, my HP plus equals 2. Now, there is a clear pattern here, and there's no reason for you to have to repeat this over and over and over again. And so, let's bring back methods. All we have to do at the end of our main function here is write out void, and then name our function. Let's just call it hit event. Sounds good enough to me. Open, start and end parentheses, and then come down here and do our code block. And let's just write all this out. Enemy HP minus equals 1, perfect, money plus equals 5, and then my HP plus equals 2. And so now all we have to do is simply just remove all of these and replace them with hit events. Start and end parentheses, semicolon, and bada bing. Do that for all other spaces as well. And do hit events. Start and end parentheses, semicolon, oops, get rid of that line. And then of course here as well. Hits events, boom, 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 and bada bing. And there you have it. We have greatly reduced our repetition. And of course, just to prove to you that all this works, I'm gonna come to the end of our script here, which again ends right before our method is called. So end of script. And then I'm going to add a console.writeLine. And we really just want to know all of our variables. So enemy HP. And then I'm lazy, so I'm going to hit Control C, Control V a couple times, and then replace this with money. And then replace this with my HP. Come up here, hit the start button. Oh, it's going to close, of course. We have to add console.readKey. I always forget this. Probably a bit too used to Python. Hit play, bring the window over, and you can see that we have our calculations. I mean, I'm not going to confirm that they are what they are, but trust me, it's working. And now over in Python, this technique has a lot of benefits, but it's still limited to the order of operation. And so again, to implement this in Python, we simply just go after our variables that we're using are initialized, but before we call it, which that sweet spot is right here. And so we can do def. What do we call it? I forget. Hit event, and then start and end parentheses there. And then I forgot just regular colon. And our code block, we can just bring in this right here. I'm lazy, so I'm just copy and paste it. Bada bing. And then we can replace all of these with hit events. And then I'm going to copy this because I am lazy, and copy this as well because I'm lazy. And you can see that we have our issue again. And you can see that we have our scoping issue again. And you can see that we have our scoping issue again. And you can see that we have our scoping issue again. And to fix this, all we have to do is just again add our global, and then we need what, enemy HP and money. Perfect. And so now to prove all this works, I'm just simply going to repeat what we did in C#. I'm going to do print enemy HP, and then we also want to print our money, and then we also want to print our my HP. Bada boom. Except for the HP, of course, because we didn't add that. But it's a lot easier to add things now. Instead of having to go through every single event, we just go to the actual hit event method, and then we can do my HP plus equals 2, I believe it was. Let me just double check here. Yes, it was 2. And we need to set that as a global as well to grab that from our scripts. And then I can hit play again, and you can see that we have the same exact variables, 27, 15, and 16. And there you have it for reducing repetition with methods. Now, I just want to show you one last technique with methods, and that is returning values. To do this, again, I'm just going to get rid of all the code that we did already, same with Python. And now imagine this scenario. And so I went ahead and wrote this scenario off code off camera, because otherwise this probably would have been about a 10-minute silence. But as always, I'll walk you through it. First, consider the scenario that you're developing some app or some social media or something like that, and you want to generate a user ranking for all of your users. Now, what's going on in our program isn't really important at all, honestly, but here we have our user rank variable, and let's say that we want to generate this user rank using these variables here. Well, I just came down here and just made a pretty big tree and did a bunch of checks. So if guest, then minus something, if page, plus something else, plus this is all arbitrary. I just wanted to make a really big tree to demonstrate this next example. So let's just say that all of this right here, actually starting here, all this right here is like an algorithm that you and your social media or your app team has developed, and you guys have concluded that it's a very accurate way to assess the user ranking of your users. Well, instead of having this algorithm hard-coded for a single variable, we can convert this algorithm into a method and have that method return a value. And so to do that, we only need to do two things. First, let's convert this algorithm into a method. Now, this is still hard-coding our user rank variable. This is no different than just a regular method. So what we need to do next is we need to create a temporary variable. I'm gonna call it actually temp, and then let's set it equals 0. And then we need to change all the user ranks to be temps, or the temp variable, my apologies. So I'm gonna say temp here, user rank, I'm gonna go right here, temp, and then user rank here is also temp, and then user rank here is also temp, and then user rank here is also temp. This user rank is temp as well. And this final one is temp. At last, and all we have to do is come to the end of our method and then do return temp. Now, you'll see that we will get an error here. And the reason for this, it requires a bit of explanation. So when you initialize methods, you are also casting its data type. And so if we check out our score method, you can see the data type for our score method is a void, which is essentially data type lists. So our score method will essentially just go through its code block, run that, and then exit out. But if we wanted to return data of some type, all we have to do is replace this with that data type. And seeing that our user rank is a float, we're going to replace this with a float. And you see our error has disappeared. And so what does that allow us to do? Well, I'm going to do our convention. Our program ends here. And then I'm gonna go down and find these two things and then Control X to cut them. And then I'm put them before our program ends. And now all we have to do is just assign score to our user rank variable. Isn't that nice? And let's say that we have another user rank that we want to calculate, right? This is user rank 2 equals 0. Well, all we have to do now is just go user rank 2 equals score. And over in Python, we can do the same exact thing. Just first wrap our algorithm here into a method. What is it called? Score. And do that. And then now we need to select the entire algorithm and then hit the tab button so that it is all within the code block for score. And then because it's a method, oh, something broke here. What broke here? Now I'm not entirely sure what happened here, but to fix this, we simply just add a tab, fix the syntax, error disappears. Perfect. Next, we need to add back in our temp variable. Let's just initialize this, temp equals 0. And then let's replace all the user ranks with temp. I'm just gonna copy and paste because I am pretty lazy right now. Temp, 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 and then at last we just come out. I think this is it. Return temp. Just gonna double check this is the right place to put it. Yes, it is. Now again, because this is Python, this method isn't that useful for compression. Again, it has to be in that sweet spot, but we can get our user ranking simply by calling user rank and then assigning a score to it. And so now to prove to you that these do exactly as I say they do, over here in C# on the left, I'm just gonna copy and paste this right line because I'm lazy, then add a 2 there, and then we have a read key. So now I'm gonna hit the start button, and then I'm gonna bring the window over, and you can see that we have 49 and 49. And to prove the same thing to you in Python, I'm just gonna initialize a new user rank here, user rank 2, and that also equals score, just so we have the same exact scenario. And then I'm gonna print user rank 2. And then I'm gonna hit the play button up here. You can see we have 49 and 49. And yeah, there you have it. If you want to learn more about methods, I think the best thing that you can do is just to start using them more because you'll learn more about them in the process. But that is everything that you need to get started with programming in regards to methods. Functions. Let's step into the wonderful world of functions. Now, I'll just go on record saying this. Functions are hands down the most valuable tool to programming. Now, why is that? Well, functions share a lot of commonality with methods, for they allow you to be able to reuse code, giving you the ability to write more neat and nice code, which in effect makes it easier to read, giving you a better grasp on your code. But the advantage that functions have over methods is that you can pass in data and slightly alter the code that is ran within a function, making them extremely powerful. So, for example, say you have an inventory class that can hold 4 items and you want to remove the items. Well, instead of creating 4 different methods that you can call to remove the 4 various items, inventory.removeItem1, inventory.removeItem2, so on and so forth, that will all run the same exact code minus maybe a variable or 2. With functions, you can pass in, for example, the item number, and using the same code can remove that item. Now, talking about the theory of functions is great and all, but let's take a look at how to use functions practically with code, because I promise this will become so much easier to understand. And we're going to do this using 2 different languages, because I think it can be really helpful for you to see how they compare and contrast. And plus, you'll pretty much learn 2 languages at once. So on the left is the language C# using the IDE Visual Studio, which should interest you if you want to do Windows development or make games using a popular game engine called Unity. And on the right is the language Python 3 using the IDE Visual Studio Code, which should interest you if you want to get into more general programming or data science. Alright, so here I have 2 brand new console projects, and if you don't know how to make a new console project in either C# or Python or both, be sure to check out the video in the description. It's called How to Install an IDE, and at the end of that video I'll show you how to do that. Alright, who's ready to have some fun with some functions? Now, before we can do that, we need to go over the syntax for functions in both C# and Python. Over here on the left in C#, I'm going to get rid of these 2 lines. They come standard with every new console project, but I don't need them. And then in this code block, I'm going to initialize a function, which if you're familiar at all with methods, this is going to seem very familiar to you. I'm just going to type out void and then the name of our function, which I'm just call f for now, and then start and end parentheses. Now, if you're familiar at all with methods, you're probably looking at this and you're like, wait a second, that's just a method. What's going on here? And yes, you're right. Methods and functions have a lot of overlap. But what makes functions super cool and extremely useful is that you can pass in some input. So if I type in right here, if I initialize an int, and then I'm going to call this x for f of x, that's a standard notation for functions. I can now make my code block here, and we can do something with this input within the code block. For example, let's say that we want to take our input x and we simply just want to times it by 2. So I'll use the multiplication operator and then times it by 2. And then to see this change, let's come down here and add a console.writeLine just to print to the console. And then we're going to put in here our x variable. Well, now we can do something cool with this function. If I just come to the beginning of the script and then I'm going to initialize an integer, I'm going to call it, I don't know, my number, for example, and then let's make it 9. And so now I just want to call f and then pass in my number, which is 9. And what it's going to do is it's going to take my number in this function, and in here it's just going to times by 2 and print it out. And to prove that to you, I'm going to come right underneath our function and add a console.read key so that the terminal doesn't close on us as soon as we run it. Hit the start button, and our terminal is over here. You can see that 9 times 2 does in fact equal 18. Now in Python, the syntax is a bit different. I'm just going to start off by initializing our integer, my num, assign a 9 to it, and then our function has to come before we actually call it. So I'm going to initialize that first. I'm going to say def with the name f, and then we're going to pass in our input x, and then I'm going to use a colon here, go down into the code block, and then I'm going to do x times equals 2, no different than what we did in C#, and then simply just print out whatever x is. Then lastly, we can just call our f function by saying f and then passing in my num, my num, and there you have it. Gonna press the play button just to prove to you this works, and bada boom, you see that we have 18. Now, we just barely scratched the surface with functions, but hopefully you can already see how much power we have with just this very simple example. Allow me to show you one more example before we move on. Imagine that we have a list of names and we want to add Mr. or Mrs. to the beginning of those names. Well, we can simply get rid of this integer, no longer need that. What else do we don't need? We actually don't need this function anymore, so we don't need this. We'll keep the console. Actually, let's just get rid of the whole entire program. Let's start over from scratch. I'll do the same for Python. So let's initialize a string array. Let's call it name, and then that equals a new string array of size. Let's initialize the size of 3, make it simple. And then we can come in here and manually set the variables within our array. So I'll do 0 equals let's say his name is Johnny, and then let's say that name of element 1 is equal to Carla, and then name of element 2 is equal to, let's just say, Zach. Can I spell Zach? Thank you. So now let's write out our function that will do this process for us. I'm going to come down here and I'm going to do a void, and then let's call it surname. I believe they're surnames. And then we can pass in, let's see, a string, and this is going to be, let's call it sir as the variable. And so now we can do down here, name of 0 equals sir plus name of 0. And then of course let's print this out so that we can see what's going on. Console.writeLine, that's what I'm looking for, and we can print out name of 0. Come on, there we are. And then we can call our surname here, and then let's pass in Mr. Mr. with the space there, and then of course console dot read key, so that terminal doesn't close on us. Also, I'm just gonna write right here just because it's fun to make the distinction that our program ends here. And so I went ahead and wrote out the program in Python so you don't have to sit and listen to my silence for a couple of minutes. But it does the same exact thing. We have the name list here that is initialized with Johnny, Carla, and Zach in it. And then we initialize our surname function that takes the input of sir. And we essentially just assign sir plus the name of element 0 to name of element 0, so we just essentially reassign it, and then we print it out, and here is when we call the actual function itself. And so if I just come up here to the play button and press it, you can see that again we have Mr. Johnny, except for I put the period in the wrong spot. It's supposed to go there. Press it again, bada boom. All right, cool. So now we have a surname function that adds a surname to our names. However, we have 3 names, and I really don't want to have to write 3 different functions just to do this. Well, thankfully, we don't have to, thanks to this next feature that further makes functions even more powerful. So there is no real limit on how many inputs we can pass in with our function. And at the fact that we're using an array here, we can just pass an integer to change whatever element in the name array that we want. And so to do that, I'm just going to add an integer variable at the beginning here. I'm just call it IND for index. And then we can simply just replace this 0 here with IND, whatever integer we pass in, IND again, and then IND. And lastly, we just come up here and then just pass in the 0. So we want to change the 0 element in the name array, which corresponds to Johnny. Run that again by hitting the play button at the top here, bring the console window over, and you can see nothing has changed. And so now that we have this added flexibility, I can simply take this line and copy and paste, copy and paste, copy and paste, and just change the index to 1, which is Carla, and 2, which is Zach. And of course, Carla is not a Mr., so we can change that to a Mrs. here. And when we run this, it's going to print out all 3 of them. So I'll just press the play button again and bring the window over. And would you look at that? Mr. Johnny, Mrs. Carla, and Mr. Zach. Function is working perfectly. And over in Python, we can do the same exact thing. So I'm going to pass in an input variable here called IND again. Separate them with the comma. That's important for both syntaxes. Separate your variables with commas. And then we can replace all of the element numbers here with IND. And then just pass the integer in when we call the function. Let me get there right here. So Mr. 0. And then of course we can do copy, paste, paste, and then 1 and 2. Carla is a Mrs. Hit the save button, clears all errors. Then we hit the play button, and would you look at that? Mr. Johnny, Mrs. Carla, and Mr. Zach. I'll never stop saying this, but functions are the greatest thing there is. I love functions. And if you think that it stops there, well, you're in for a bit of a surprise. But first, let me introduce a problem to you. Say that we wanted to come down to the bottom of our program and initialize a new string, right? And the name here, let's just say this is the boss's name, and it equals Helen. And now, what if we wanted to add a surname to Helen's name? Well, because this surname function is directly tied to the name array, we kind of can't at the moment. I mean, of course, we could just come in here and just add it manually, Mrs. Helen, or we could remove this and then just come down to the next line and do something like boss equals, Mrs. plus boss here. And then we also want to do a console dot. Yeah, we could redo the same code over if we really wanted to. Imagine that you were doing this as an automated task. Well, you wouldn't want to manually go and add the surname to all the names that you have, and you wouldn't really want to rewrite the code over and over and over. And so the solution to this problem is by changing this function from being a variable dependent function into a variable independent function. And we can do that by using the return statement. And so to do that, first I'm gonna get rid of these 2 lines because they're just for an example. And then I'm gonna go into our surname function and we're gonna return a string. So I'll initialize a string, I'll call it temp, and then I'll assign it to be an empty string for now. And now we have to replace all of the variable references to the name array into the temp, because this is what makes this function variable dependent. So I'm going to change this here to temp, and then I'm going to change this one to temp as well. And then I'm going to change this here to temp. And actually, because we need to input what the original name is, we actually don't need to initialize this here. So I'm going to get rid of that line, and we can now change our integer variable input into a string variable input and call it temp. And so the very last thing we need to do here is we need to change the data type of our function from a void to be a string. And then you'll see we get an error saying that it doesn't return a value. When you cast the data type on your functions, they have to return the same type of data type in the return. So we'll go down here and add return, and temp is a string, so we'll just return back the temp, which has been modified with sir at the beginning. And so now, because we changed the input to surname from the data type integer to string, you can see that we have 3 errors here for the times that we called it. These are currently integers, they need to be strings, which is no problem. We can just input the actual name that we want to change here. So of course the first one is name of element 0, and I'm lazy, so I'm gonna copy and paste this, paste and change this to 1 and 2, which again corresponds here. And if I just hit save and then the start button up here and then bring the console over, you can see that absolutely nothing has changed. Function works exactly the same. However, the very last thing that we have to do to make this completely functional is, again, right here, it's printing out the temp. So this is only temporary. We get a reference to that and then we change it and then we return it. But you can see here that's it's not being assigned to anything. So that's the final thing that we have to do here. But before we do, to further illustrate my point, I'll simply come at the bottom here and do a console.writeLine, and then we're going to print out name 0, and then I'm going to copy paste a few times because I'm lazy, change it to 1 and 2. And so if I come up here and hit the start button and bring the console window over, you can see that yes, the surnames were added for the first 3, which is what is inside the actual surname function, but the last 3 that were printed, which is outside the surname function and is the actual ground truth to our name of 0 element, name of 1 element, and name of 2 element, are still the same exact as we initialized it. And so to fix this, we simply just have to assign it whatever is being returned right here. So name of 0 equals surname with the inputs, and name of 1 equals surname with the inputs, and name of 2 equals surname with the inputs. Come up here, hit the start button, bring the window over, and you can see that they have actually been assigned. And just to walk you through what's going on here, on these 3 right here, we will assign that name of 0 element, name of 1 element, name of 2 element will equal surname with some inputs. And so we go into the function and we pass in the inputs temp, which is the actual name at the moment, and then surname is the name that we want to add to the beginning of the name. And so we will assign the surname to the beginning of the name, and then we will print that out, and then we will return temp. And so because this whole function right here is returned with the value whatever temp is, which again is calculated here, we will assign that return value to name of element 0, name of element 1, and name of element 2. And now, at last, to bring it full circle, now that we have this flexible variable independent function surname, we can initialize our boss string here, which equals Helen, and simply just reassign it by going boss equals surname, and then we're going to pass in boss here, and we can pass in Mrs. And As simple as that. And just to prove it to you, I'm gonna get rid of these 3 lines, make it a bit less confusing, hit the start button and bring the window over. And as you can see, we have Mr. Johnny, Mrs. Carla, Mr. Zach, and at the very end, Mrs. Helen. Now that is how you write good code. And so over in Python, we can make this change really easily as well. We can simply just change this to say temp, and then change this as well to say temp, and then change this one to say temp. And of course, we want to change our input to be temp. Oops. And then come down here, and then we want to assign this to be name of 0. And then this one to be name of 1, and then this one to be name of 2. Of course, and then we need to assign this here, name of 0 equals surname with these inputs, and then name of 1 equals surname with those inputs. And then I'm lazy, so I'm gonna copy and paste the last one, change that to 2, name is surname equals the last of those inputs. And of course, I'm getting an error here. It's saying that assigning to a function which doesn't return. I forgot to return here, so we'll simply just do return temp. And then of course, we can't forget our boss Helen, so we can initialize that by saying boss equals surname. And because we're initializing this, we simply just pass in Helen like so, and then Mrs. Can come up here, hit the play button, and voila, Mr. Johnny, Mrs. Carla, Mr. Zach, and Mrs. Helen. Functions are just absolutely incredible. I love these things. We barely scratched the surface with what's possible with functions here, but hopefully your creative juices are flowing and you're thinking of different ways on how you might be able to apply a function. I've said it before and I'll go on record saying it again. Functions are probably the most powerful tool when it comes to programming. In fact, if you're familiar at all with all the breakthrough research that's happening in the field of machine learning, well, it's all powered by functions. So I hope I was helpful for getting you excited about some functions. But that's everything you need to know to get started with programming in regards to functions. Now, commenting can be a make or break for your coding success, especially if you're working on a team, on an open source project, or on a project you plan to work on long term. Comments, just as you expect, are a way to leave comments within your code in a human readable format so that you know what's going on in different parts of your code at all times. Sometimes, you'll write out extremely complicated code that makes perfect sense in the moment, but when you return to that code months later, or give it to someone else so they can add on to it, it may be really difficult or a ton of wasted time trying to reverse engineer the code. So let's take a look at how to use commenting in 2 different languages, because I think it can be really helpful for you to see how they compare and contrast. And plus, you'll pretty much learn 2 languages at once. So on the left is the language C# using the IDE Visual Studio, which should interest you if you want to do Windows development or make games using a popular game engine called Unity. And on the right is the language Python 3 using the IDE Visual Studio Code, which should interest you if you want to get into more general programming or data science. Alright, so here I have 2 brand new console projects, and if you don't know how to make a new console project in either C# or Python or both, be sure to check out the video in the description. It's called How to Install an IDE, and at the end of that video I'll show you how to do that. Alright, so the first thing I want to go over is line commenting. So over in C# on the left, I'm just going to remove these 2 lines that come stock with every new C# project, and I'm gonna start creating a little fake project. So I'm going to initialize a couple of floats. I'm gonna call this location X. I'm just gonna do 1.2.345 F, and then I'm gonna do another one, float location Y. I'm gonna do 1.2.3.456. All right. Oh, F. Sorry. Alright, so these variables are just going to act as fake coordinates for a little example. So I'm going to create a more involved boolean. I'm going to say bool in position, let's say in pause, equals, and let's do location X is greater than, I don't know, let's just say 12, right? And then we'll also check if location y is less than 30, for example. But then outside of that, we'll also check, or if I'm about to go off screen here, I'll scoot over, or if location x is greater than location y, and then we'll put a semicolon. And now we have a more involved Boolean. All right, so here we have maybe one of the greatest examples of how line commenting is pretty useful, or can be pretty useful rather. I'm going to go on top of our Boolean here and just going to do //. And that right there, it starts our comment, and we can write whatever we want. So I'm just going to do my best to explain what this Boolean does. So if location x is greater than 12, and location y is greater, oh no, less than 30, or if location x is greater than location y, then we are in position. Sorry, it's a bit long and it doesn't exactly fit with the rest of the code, but that is how you write a line comment. And the way it works is when your code is compiled, anytime that the compiler sees a double // it knows to ignore everything after it. So just pretty much we'll go to the next line. And over in Python, it's a lot of the same. I'm just going to do loc x equals 12.345, and then loc y equals 123.456, and then I'm going to do in pos equals, let's see, loc x is greater than 12, and what is the loc y is less than 30, or what we have, loc I already forgot, x is greater than loc y. Boy, that was brutal. And to add our comment, I'm just going to come over here above our in position variable, and instead of doing // that form of currency is not accepted in Python, I'm going to hit the pound sign or the hashtag, whatever you call it, and then I'm just going to write out our message. So I'm not going to write it because that's going to take forever again. I'm going to copy it from here and then paste it, and there we go. Comment and comment. Sorry, I just realized the Python font should probably be a bit bigger, so I'm just going to make that a bit bigger. Yeah. So that's one use case for line commenting, probably one of the most useful cases for line commenting. However, you can do something else as well. So let's say that, we try out this Boolean and it just isn't working right for whatever reason. Well, we can do a line comment on everything after the assignment operator, and then just put, like, for example, equals 1, just to make sure that, we actually need to put like true here, just to make sure that this Boolean is actually working, just for example. And then in Python, it's all the same. You just do hashtag, everything after that's ignored, and we just put true, no semicolon. And yep, that's another use case that can be quite handy as well when debugging your code. And so the final use case I want to show you with line commenting is, let's say that we're going to return these back to that assignment, and let's come down here and then let's add an if statement. So if in position, right, we want something to happen. However, we don't exactly know what we want to happen yet. We have an idea, maybe we don't know how to do it. Maybe you want someone else to do it. Well, what we can do here is just add a comment on, like, here I want to display something, some notification. I don't know. I just want to display something here. And you can leave this comment here, maybe come back to it later, maybe give it to a friend, maybe do some research and then, learn how to do it and then implement it. This comment is just an easy way for you to, know what your intent was with putting this if statement there. And in Python, it's really similar, but a little different. So let's say we do our if statement, if in position. We'll come down here, we can write our comment, which was again copy and paste. Copy, paste. However, we can't leave it like this. You see, if we hit save, we'll have a problem, which is we have a parsing error, a syntax error rather. And the reason is because if you do an if statement and then you indent, which you have to do, there's nothing when it runs this if statement. It's not going to run anything, and that's a syntax error in Python. So we can just simply put like print, 0, for instance, just so that it clears that syntax error. And technically speaking, you don't even have to do a print. For example, you can just do like empty quotes. Whoops. You can just do like empty quotes and that will work just the same, but it has to run something within the indentation because again, this line is ignored. All right, so that was line commenting. Next, I want to talk about block commenting. So to demonstrate, I'm just going to get rid of all this code that we just did. And then, and then I'm going to, let's just say that you're creating some like complex algorithm that you quite understand, but you kind of don't understand. So I'm just going to create something. This is just a representation for an advanced algorithm. Just use your imagination. Let's do loc y divided by equals 4, right? And then we need to return it or something like that. So we'll do loc new equals loc y divided by loc x, for example. Oh, I have to initialize that. This is not Python. Floats. And then finally, let's just return it. Let's do this. Console dot write line location new. All right. So let's just say this is some advanced algorithm and you just implemented it in your program, but all of a sudden, like, everything's broken. Nothing works anymore. You're like, what's going on? This isn't behavior that I expect. I know that this is working right. This is obviously, very straightforward, but maybe this part of the algorithm isn't working right. Now, you could, go by and do like, // // // and if you have a bunch of these, do that line by line. But one really convenient way is to use block commenting, which in C# is just one / and then an asterisk. And you have to end it doing the opposite. So an asterisk and then one /. And that is one way that you can quickly comment a whole block of code. Now, one really important thing to take note of with block commenting is that you have to have a start and you have to have an end. Because if you don't have an end, what happens here is that it comments out everything after it, including the brackets. And if the brackets has a start but it doesn't have an end, you're going to get a bunch of errors. So they always have to have a start and they always have to have an end. Now in Python, I'm just going to replicate our super advanced algorithm here. I'm going to do loc x times equals 2 and then loc y divided by equals 4, and then we're going to do loc new equals loc y divided by loc x. Then we'll just print it because why not? Loc new. And to add block commenting in Python, it's similar but also very different. What I mean by that is you want to come up to above wherever you want to do your block comment and just do 3 single quotes. And again, it needs a start and it needs a finish. If you do not have a finish, you are going to get a syntax error because it needs a start and a finish for the triple quoted string literal, aka the block comment. Now, the very last type of comment that I want to go over is summary commenting. So to demonstrate, I'm just going to get rid of all this code. It is no longer needed. And then I'm just going to initialize a float variable. Let's call it loc equals 0, for example. Next, let's create a quick little function. I'm gonna go outside of our main function and then do static float. Let's call it ret1, and then let's pass in a float, and then we'll call our float a, just to make it easy. And then what we're going to do is we're going to return a, let's see, a plus 1. That's what we're going to return. And then let's just use it real quick. So we'll do loc equals ret1, and then we'll just pass in itself. So it's going to plus 1 to itself, and just to prove that, we'll do console.writeLine. Even though it's not about proving in this, it's really about comments, but we'll just do that anyway. Console.readKey. And then I will hit the play button, and boom, there we go. 0 plus 1 equals 1. So our function works, but let's say that, you know, it's later down the line in your project and you come back to the script to upgrade or fix something. You see that loc equals ret1. What does that do? And you go down to the ret1 function, and let's say this is a lot more complex. You don't really understand what's going on. Well, you might waste a lot of time reverse engineering to figure out what that function is. But what can solve that is by adding a summary comment. So adding summary comments in C# is actually really easy. All you have to do is go right above whatever function that you want to add a summary to or method, and just hit \\\\. It will autocomplete if you're in Visual Studio. You can just fill in whatever your summary is. So I'm going to do +1 to the input. Now, if I go over the ret1, you'll see that now there's a little description there that tells me exactly what it does. It pluses 1 to whatever the input is. The input is loc, so it's going to be loc plus 1 is what it's going to return. Simple, easy, and to the point. And they also have some other variables that you can fill in. You can fill in like whatever the parameter A is. You can put out what that is for. You can put out what it returns. And in the right context, it will display that information for you as well. And over in Python, I'm just going to get rid of everything and set up our scenario real quick. So loc equals 0, then we need to do def ret1, and then we need our A input, and then let's see, return A plus 1, and then we just simply do loc equals ret1, and then pass in loc, and then we can print loc out, and then we don't need a input. And just to prove that it works, I'm gonna hit play up here, and you see that we have a 1. Now, to add summary comments to Python methods and functions, all you have to do is go right under the method or function in Python, and then hit 3 single quote characters, and then another one. So you pretty much block comment, and then you just type whatever the function is. I'm just gonna copy this because I'm lazy, and then I'm gonna paste it here. And so now if we go over here, it shows you what it does. The definition ret1, it pluses 1 to the user. To the input. And then we can add more if you want, like A equals, a float, for instance, just more information for the user. And that's pretty much all there's to it. And there you have it, guys. That is pretty much everything you need to know to get started with programming in terms of commenting. Well, all right, congratulations. You fully made it through the course. Now, how do you think you did? If you really aren't sure, you should go back to your first program lesson in section 4 and retry it on a different tier. If you're able to complete your first program on its hardest difficulty, then you know you are officially ready to go out into the world to find your own problems to solve and code up your own ideas with your newfound skill. But before I let you go completely, I just want to pump you with some inspiration on the cool possibilities that you can take with this skill from here. With more practice, of course. But I just want you to think about everything you do these days. Just think about the fact that almost everything you interact with in this new digital age is some way determined by code. online banking, offline banking, text messaging, tweeting, watching this very YouTube video, even driving your smart car now, or using your smart toothbrush, unlock your home with your smart lock, or even using your smart thermometer. The list goes on and on and on. And of course, from this day on, that list is only going to grow larger. Our world is becoming more and more dependent on programs running the show, which is a whole other conversation. But again, congrats, because you at least now have what it takes to better understand and contribute to that landscape. I wish you and your coding adventures nothing but the best. And the last thing I want to leave you with is this bit of advice. You're guaranteed to do amazing things with code, so long as you follow this final rule. Remember to always feed your curiosity.